My dear 12th standard students, welcome. This is your Captain Shreyas on the Vedantu J English channel. And on popular demand, many kids after Diwali realizing that the boards, the pre-boards, the prelims are so close by, and you wanted us to take dedicated sessions for your board preparation, for your CBSE preparation. You wanted NCRT book to be analyzed, to be used, to be gone in depth for your 2026 class 12th board examination. And here we are. I hope I'm audible and visible to all of you. Let me know quickly in the chat box. And this is the session which is on demand. Just a couple of days back, I had already mentioned the high weightage topics for getting easily 75% and above score. But we are targeting 65 plus out of 70 from your theory paper. Okay, so let's get started. It's going to be a big marathon. We are going to cater to all the topics which are frequently asked, which are very important and very high priority and high weightage. I will start off with the theory or the concept, whatever is important, and then we will go to some assertion reasons, some question answers, some give reasoning or numericals, or the questions which are most likely going to be asked or have been repeated several times in the previous year papers. Okay, so you're going to have questions practice, all kinds, as well as the topics coverage in this particular session. So let's get started, my dear warriors, with your Captain Shreyas. And if you're not yet registered for the MBSAT examination online, remember the last date is actually 28th of October, but it has been extended till 2nd of November. It's an online test where you get to know not just where you stand, but lot of other things like what kind of a learner are you. It's a cognitive skills report card that you get, and also a lot of resources, free resources, which you get after you attempt the test. Doesn't matter what marks you get, you are getting a lot of free resources for your board preparation, for your JEE preparation, and a lot of question banks which are a part of MVSAT. And of course, if you win it, you're getting a lot of prizes as well. All right. So let's begin with the class, my dear warriors. Let me just say hello, hi to all of you out here on the channel, and let's just open up the chats. Yes, this is of course for board preparation. Hi Akshita, hi, I'm Chef. Welcome Anbu, Chris. MVSAT results will be out by maybe second week of November, and you can hear me and see me, right? And you guys are ready for the marathon, I believe. Welcome aboard. Welcome aboard. Yes. Hi Chaitu, hi Black Dragon. Good evening everyone. And smash this like button right down over here. And yes, the MVSAT registration link is right over here. You can see it. And the Ekalavya test series for JEE, that is also available here. It is for 1999 exclusively for JEE mains preparation for all of you. Okay, based on the high weightage topics. This is the MVSAT registration form link. Open this up. You can see all the details have been mentioned along with FAQs, and lakhs of students have registered. So just click on register now and you are done and dusted. Cool. So let's begin. Duration may be around 3 to 5 hours. We'll see how it goes. Okay. So let's begin with the class. And here is the first topic. I'm going to go sequentially, guys, chapter by chapter. If there is something which is important in a chapter, that is only what is being discussed. If something which is not important in a chapter, that will not be discussed, because we are prioritizing high weightage subtopics or articles. Okay, that is our priority right now. All right. Now, Coulomb's law, the formula, the vector form, and the superpositioning principle. Charges which are there in our atoms or molecules or bodies, they are either positive or negative or neutral. Example of a positive is a proton. Example of a negative is an electron. Example of a neutral charge is a neutron. These charges can attract or repel or maybe apply no force on each other, depending on what kind of charges they have. Like positive or negative will repel each other, whereas oppositely charged, one positive, one negative, like a proton and electron, will attract each other. Is that right? Now, how much is the force of attraction or repulsion between those charges is given by the formula of Coulomb's law. Now, what does this Coulomb law say? It says that, see, if if basically if basically you have two charges over here, this is q1 and this is q2, and the distance of separation between them is nothing but r, then there will be some kind of force, either attraction or repulsion, depending on the sign of the charges. By the way, the forces are always equal and opposite. It's not a question of ego between the charges, who will apply more force. Irrespective of this being big or small, or this is small or this is big, doesn't really matter. Both the forces will be always equal and opposite by Newton's third law. Now, this force particularly is proportional to, this force is proportional to the product of the charges, and it is inversely proportional to the square of the distance between them. That is why sometimes it is also called as inverse square law. This could be a one-liner or two-liner question where they might ask you, what is the meaning of an inverse square law? A law where the force is inversely proportional to the square of the distance, that is called as an inverse square law. Okay, that is what it is. Having said that, you can see the formula is some constant q1 q2 by r square. That constant of proportionality, which you have, is called as the Coulomb constant. 1 by 4 pi epsilon naught is called as the Coulomb constant, and that Coulomb constant is nothing but 9 into 10 to the power 9, okay, Newton meter square per Coulomb square. That is the unit, SI unit, and this is the value of the constant, 9 into 10 to the power 9. Is that right? Yeah, perfect. Sir, do you know, I'm not really sure, Sham. No, I don't think so. Yes, Black Dragon, I will let you know about the CBSE 2026 crash course also, if at all. Definitely. Having said that, this epsilon naught that you see over here, that is called permittivity of vacuum. That is called permittivity of vacuum, who has an approx value of 8.85 into 10 to the power minus 12. 10 to the power minus 12, exact opposite unit, Coulomb square per Newton meter square. Okay, so this is the permittivity of vacuum, which is there in that constant of this particular formula, which you should know. This permittivity can change from medium to medium. All right. Okay. So all this has been said, and the force always acts along the line joining the charges. So if they ask you a question on describe Coulomb's law, and it might be a 3-marker question or whatever, then you have to give all the points. Like, you start off with this, the force is proportional, it is inversely proportional. You mention the constant, the permittivity. You also show the diagram. You also mention this point, that the force is along the line joining the charges. Very, very important point. Else you will lose half a mark. And it is repulsive for like charges and attractive for unlike charges. If you mention all of this, then you'll get full 2-3 marks. Got it? Even if it is 2-mark question, doesn't matter. Give this point wise, and also block the formula, obviously, for all the kind of theory questions. Okay. Now let's talk about the vector formula of the Coulomb's law. That is also very important. Let's have a look at it. The vector formula. So say, for example, again, let's take this as charge 1, this as charge 2, and now carefully analyze this. Imagine I take a position vector, which is called position of 2 with respect to 1. This is very important, what I am writing it as. R21 is the position, whose position? Of the charge Q2, but from where? From, or with respect to the first charge. This is a vector. Wherever the second charge is, I am directing a vector towards it. Then I can make a unit vector which is in the same direction, R21 hat. So this is nothing but a unit vector, and a unit vector is nothing but the vector itself divided by the magnitude of it. This is nothing but a unit position vector. Unit position vector. A vector, let's say of length 7, a unit vector will be 1 unit. If this is 8, this is 1 unit. So this 1 will come 8 times or 7 times or 16 times depending on the length or the distance between them. It's a value having unity. Okay. Then this formula you have learned it in vectors chapter 11th standard, vector by magnitude. If it is whatever vector divided by magnitude is the unit vector. Then the force acting, then the force acting, then the force which is acting on to because of 1. This is very important. This F21. What is this F21? You have to describe all of this. Why am I writing it? It's not that you do not know it or maybe I do not know it. No, I'm telling you what are the steps involved when you have to describe the question in express the Coulomb's law in vector form. You have to mention all these lines. Only then you will get 2 marks. You might be a JEE student. You might know this mentally or you might not be even using this. But that is precisely where you lose marks in your board exam. Okay, that is why I'm conducting a dedicated CBSE board session over here, and that's why you should be subscribed on the channel. If you have not yet subscribed, please do that, because every year we do conduct CBSE classes apart from our JEE classes, so and that too in pure English. So if you have not yet subscribed, subscribe and like this video. So F21 is nothing but the force on to due to 1 because of 1 due to the charge 1. So that force on to because of 1 is given by, first of all, that constant which is there, which is 1 by 4 pi epsilon naught. Then you also have the product of the charges, which is q1, q2. Here comes the fancy part. You have the distance between them, which is r21 squared. But here you will put the unit vector. You can see the direction is same as this. So you will put r21 hat. You'll just put r21 hat. So now this part becomes your magnitude. This part becomes your magnitude part. If you write it down like this, no, the teacher will be super duper impressed. And this part is nothing but the directional part. So that is how magnitude and direction to gives me the net vector force. Is that absolutely clear? How to represent it, everyone? Yeah. Yes, the CBSE 2025 physics paper was hard for certain people, certain sets, but certain sets were average only. So you have to prepare for the hardest set, because then it's a game of dice that you are playing. You do not know which set you will get. So you better prepare for the hardest paper. So you should think the paper was actually hard. Okay. Right. Sir, can you do a separate session for all the derivations? See, I am like the genie that you have. You just asked me and I will give you that thing. Derivation. Derivations were not so important, but still I have done it for you. Do you see this? CBSE class 12 important derivations. It's a 6 hours plus class. Only derivations of class 12 NCERT. All derivations included. So please do that. It's got good response and also very important. But let me tell you, do not just depend on this session, because not many derivations are asked every time. In fact, some years no derivation was asked, suddenly one derivation is asked, suddenly 3 derivations are asked. So if it comes, then you have to do it. You have no choice. But there are very few questions which are just purely derivations. Let me also tell you that. But I have made that session for you. You can just search for derivation on the Vedantu JEE English channel. And if you're not yet subscribed, please subscribe, guys, or else you'll miss out on all these lectures. Okay, everything that you ask for is there over here. Okay, cool. Yeah. All right. Okay. Now, having said that, the next important thing is the principle of superposition. So they can ask you, explain the principle of superposition. This can be a 1-2 mark kind of a question, or it can be probably like an objective question also. Okay. So the net force on any charge, 3 important points. The net force on any charge is the vector sum of all the forces due to other charges. So if you take a charge and if you want to find the net force on it because of the surrounding charges, maybe protons, electrons. So you take the forces due to all the charges and you do a vector addition, which you have learnt in 11th standard. The forces add up independently of each other. This is also an important line, meaning if there is a proton somewhere applying a force on you, that electron cannot decide what this force will be, because that electron will independently apply its own force. It cannot tell proton, hey, I am there. You cannot apply more or less force. It cannot tell anything. Same way, this proton cannot tell that electron, hey, I am there. You should not apply any force, or you should apply the force here. You should apply less force. It cannot tell anything. You do your work, I will do my work. That's how it is. So that's why independently of each other, it is used to find the resultant. So first is explaining that law. Second is telling you about independence, and the third one is the application part. It is used to find the resultant field or force when multiple things are present. So when do you use it, what is it, and the special thing, which is the independence part. So when you have to show it in a diagram form, you generally show it like this. Say for example, this is the charge which we are talking about, on which we have to find the force due to charge q1, then q2 and q3 and q4, q5, and like that till qn. Then what you need to do, you just start joining a line from each of these charges to this particular charge like this. Okay, so many charges like that will be there, and now start showing the forces due to all of them. Charge 1 might be attractive in nature, maybe. Okay, it could be anything, we do not know. Maybe charge 2 is repelling, then charge n is maybe repelling or attracting, doesn't matter, guys. So just start showing all the forces one by one. So this diagram is very important. F1, then maybe F2, then maybe Fn, like that. Okay, so many other forces will be there. So the vector sum of all of them, might be like this. So this is that resultant force, this is that resultant force, and this resultant force, this is the net force, is nothing but the vector sum of F1 plus F2, like that till Fn. Okay, so if you show that, you will 100% get full marks, and you have to also apply it, not just remember it, but also apply this. Okay, right. So we'll be doing, Aditya, more sessions on CBSE board, those kind of sessions also, where the tough questions will be solving apart from the basic ones and moderate ones. So that way you will be able to prepare for even the tough papers. Okay, cool. So let's go ahead and solve some questions coming up on your screen. Here it is. The first one, the three charges are placed as shown over here, and the magnitude of the net force on this charge is asked. Do you realize that there are two charges present around the first charge? So both of them will apply forces independently, and we have to find the net force. That means we have to use the principle of superpositioning. So if you use this line, you will definitely have an advantage, in the theory paper. So what you need to do in this particular scenario? First of all, we can say by superpositioning principle, by superpositioning principle, by superpositioning principle or law, by superpositioning principle or law, the net force on it is force due to the first charge plus force due to the second charge, and that's all. Two charges are there, so two forces. Where are those two forces? Let me show. This charge on this charge will be a repulsive force because both are of the same sign, but this is negative, this is positive. So negative will always attract, so it will be in this direction. So one I can call it as force 1 over here, and this one I can just call it as force number 2 over here. Now we have to find the resultant force. Obviously the resultant force will be somewhere over here, right? This will be the net force, you can say, which we have to find. But as you can see, both the forces are perpendicular to each other. So the angle between the two vectors being added is 90 degree. So mention this over here. The angle between F1 and F2 is basically 90 degree. So therefore, F will be, use the vector addition formula, the first vector square plus the second vector square plus 2 times F1, F2 into cos of the angle between them. Cos 90 is 0. So this will just be F1 square plus F2 square. This will be just F1 square plus F2 square. But as you can see, F1, F2 values, I know it already. F1, the force on this charge due to this charge, will be Coulomb constant K, that 1 by 4 pi epsilon naught, usually I can call it K. So it will be Q into Q naught divided by whatever the distance is. So I think the distance is maybe A or something. So A square. And same way F2 magnitude wise will be Coulomb constant Q naught divided by A square. As you can see, F1 and F2 both are equal in magnitude terms, not direction. Magnitude wise, they are both equal. So if you actually put these values inside of this, it will be nothing but the same thing is coming two times. The same thing is coming two times. So two times of the same thing. So two times of whatever that same thing will come. So 2 into, so this will be 2 multiplied by that same thing square. So I can take that square's root outside. So I will just have that thing into root 2. What is that thing? That is basically Q naught divided by A square root 2. That is the answer. Understood, guys? I'm not putting the values over here, but I hope you understood it just to save time over here, right? Cool? Yeah. Niranjan, we'll be having JEE one-shot classes also later on. Okay. Great, Jeffin. Awesome. Granush, yes, that has all the derivation of class 12th NCRT for your CBSE book. Okay. Yeah, that is, I think, being shot last year only. So you can use it. It is a fresh lecture only. You can just use it because I don't want to do that again because it's the same thing. I mean, nothing new will come out of it. Plus, I feel that that 6 hours I can better utilize for more problem solving and concept clearing. Let's go to the next question coming up on your screen. And here is what it says. There are four charges. Okay, read the question, guys. There are four charges which are given. Yeah, the session PDF will get it later on, black. Okay, Black Dragon, you're going to get it tomorrow. Okay. So 4 point charges, 1, -2, 1, -2 are placed on the corners ABCD of a square. Find the net force on a 4 microcoulomb charge at the center of the square. Let us try and understand this particular question. See, the questions are straightforward, but how you write it also matters, or else you will lose marks. Okay. Say, for example, this is what my square is, and let us start labeling it. This is side A, this is side B, this is side C, this is side D. Show it exactly like this in the board examination. Now start writing down the charges which are placing 1 -2, 1 -2. So this is 1 microcoulomb. Over here, this is -2 microcoulomb. This is 1 microcoulomb. The diagram also contains some marks. Please remember that. -2 -2 microcoulomb. Okay, this is also done. Then you are placing a charge of 4 at the center. So let us draw the center of it. So if you just join the diagonals, you can easily find where the center is. So this is the center, and over here you are placing a 4 microcoulomb charge. Okay, diagram part is done. Now find the net force. For that, again we have to find individual forces to get the net force. So guys, the net force is actually the vector sum of four forces because four charges are there. So force due to charge at 1 plus force due to the charge at B or 2, force due to the charge at C plus force due to the charge at D. So these four charges will give four different forces. Let's see what they are exactly. First of all, this one on this 4 or A on this center will give a repulsive force because both are positive. So it will be in this direction. So I can call this as FA, FA force. This point C on this charge will give a force in this direction like this. So this will be force due to the charge at point C. Is that making sense? Repulsive force because they are like charges, both are positive in nature. Now this -2 on this guy, look at it, it will give attractive force because opposite charges and slightly larger vector because -2 means slightly larger magnitude. So this is the force due to the charge at point B. This -2 on this charge will also give attractive force like this. So this is force due to the charge present at D. Now you have all the forces in this particular diagram, and guess what? This FC and FA will cancel. So this is very, very important in this particular question. FC and FA, these two are equal and opposite, so they will cancel out each other. Not just that, FB and FD are also equal and opposite. FB and FD, they are also equal and opposite, so they will also cancel. Equal and opposite, that means they will cancel out each other. Now, why are they opposite? We can see it. Diagram only is showing it very obvious. But why is it equal in magnitude? That is very important for you to write it down. See, Fa, force on this charge due to A, will be Coulomb constant into charge 1, which is 1 micro, into charge 2, which is 4 micro, upon the distance between them. Let's say I call this distance as D. This will be also D, this will be also D, this will be also D. So this will be nothing but, D square, which is exactly the force due to C over here, Q1, Q2 divided by R square. So this is also FC. So you can see Fa and FC are equal. Same way, I can mention FB is equal to FD, which will be Coulomb constant into 2 microcoulomb into 4 microcoulomb, the whole thing divided by D square. So they were both equal and opposite, hence they cancel, and hence the final answer will be 0 Newton. So there will be no net force. Forces are there, but they are cancelling out each other. If you mention all these things, you get full 2 marks. Got it? Everybody? Yeah. Yes, the net force is 0. See, as a JEE student, JEE teacher, I mean, without even solving, I know the answer is 0. But that's not the whole point. I mean, the point is, how do you write it down in the examination? So this overconfidence should not kill your 65 marks out of 70 in your board theory paper. Got it? Yeah. So guys, I hope you realize the importance of, what do you say, 75% score in your board examination. Because without that, even if you have 99.99 percentile, you will not get an admission in NIT, triple ITs, IITs, all these top tier 1 institutes, right? They don't take admission. So no matter what you do. And even if you take a drop, okay, nothing changes. So unless you give the re-examination of board paper. So when you're doing it, make sure you're not aiming for 75%. We should aim for 90%. That's why I said 65 plus out of 70 in board paper. Maybe you might lose maximum 4-5 marks in practical out of 30. So even if you get 65 plus 25, then you are at 90 marks. Understood? That's how we target 90% marks. We are taking worst case scenarios. Yeah. Yes, these are NCERT book questions only. Yeah, for the hard ones, see, for getting till 85 to 90 is still straightforward. From 90 to 95 or 85 to 95, that's where the challenging questions, those case-based studies, those difficult questions are going to play a role. I will conduct special session only for that. How to improve from 75-80% to 90-95%. For that, it needs a special treatment. We cannot have the same treatment for everything, right? Okay. So let's do this, guys. A negative charge in electric field moves along the direction of the electric field. What do you suggest? What do you suggest, guys? And reason, on a negative charge, the force acts in the direction of the electric field. Okay, let's realize what it's saying. So we have a charge, a negative charge. But before that, if you have a charge which is placed in some kind of electric field, this is some kind of electric field vector, then the force vector, is given like this. The force is nothing but the charge value multiplied by the field. Okay, this is vector equation. But here comes the tricky part. We have a negative charge. So when the value of Q itself is negative, whatever is the direction of E, force will be opposite of it. So think about it. If Q is negative, whatever is the direction of that field, you will see whatever is the direction of that electric field. So only because this is a negative charge, then the force will be in the opposite direction. Yeah, force will be in the opposite direction. So negative charge in the electric field moves along the direction of the electric field. I don't think so, guys. Yeah, on a negative charge, the force acts in the direction of the electric field. I don't think so. You can see it is definitely wrong. This statement is also wrong. This statement is also wrong. Hence, both assertion and reasoning both are false. That is the right answer. D option is the right answer. Let's see how many of you get it. Very good. Anbu, Granola, amazing. Yep, very nice. Amazing. Jasper, the class will be at least for 3-4 hours. Yeah, you can expect it. Shall we go ahead, guys, to the next question on your screen? Here it comes. Okay. Assertion reasoning type of question. The equilibrium of a positive charge, test charge, is at a point O. In between them is stable for the displacements along the x-axis. This is, I think, oh, sorry, I misread the question. I have to start from here. Assertion is here. Consider two charges placed 2d distance apart. The equilibrium of this positive charge placed at point O midway is stable for displacements along x-axis. Force on a test charge is 0. What do you think about it? Okay, very interesting question. Let's see whether you can predict the answer. Okay. Now, let me explain this to you what exactly is happening. Let's look at this diagram over here. Right now, in this particular diagram, if you place any kind of charge, let's say over here, it's a small test charge. Okay, it's a small positive test charge. Then you will see this Q will apply a force like this, and this charge will also apply a force like this. So as a result, because this force and this force are equal, the net force after vector addition will be 0 because they will cancel out each other. Net force is 0. And whenever net force is 0, it is a situation of equilibrium. It is a situation of equilibrium. It is a situation of equilibrium, definitely. So whether it is stable or unstable, we will see that in a bit. Now just imagine the following two scenarios. This is your capital Q on both sides. Okay, and this is our origin. This is our origin, the midpoint. What I do now, I move that charge Q slightly onto this side. So that small q is slightly here, and in this case, I will move it slightly onto the left side. Now let's identify what will happen to the forces. Because this charge is closer to this charge, it will apply a larger repulsive force. And this charge is away from this charge, so it will apply a smaller force. So because of which the net force will be in this direction. Can you see that? The net force is in this direction. It is opposite to my displacement. In this scenario also, observe what happens. The moment I take the small q charge closer to this charge, this guy will repel it better. Okay, so there will be a large repulsion force. But this q is far away from this charge, so there will be a small repulsion over here. So as a result, the net force is in this direction. Now, because the net force is opposite to the displacement, so we can say since the net force is opposite to what? The displacement, it is definitely going to be a stable situation. It is a stable situation. That means it comes back. If you move it here, the net force will pull it back. If you move it here, the net force will pull it back. As a result, I can say it is stable. Hence, the first assertion is definitely true. Reason says force on the test charge is 0. We already saw that. But how is it explaining why it is stable? All this part was not there in the explanation or the reasoning part. Did the reasoning explain why it is stable? No. So, although reasoning is correct, but it is not the entire explanation. It is not convincing enough why the assertion is true. So, both assertion and reasoning are true, but it is not the correct explanation. That means it should be option B. Is that right? It is not A, it is option B. How many of you understood it now? Yeah, it should explain that when you move the charge closer to any charge, then the repulsion uh, uh, from one charge dominates over the repulsion of the other charge. So the net force is opposite to the displacement and it tries to bring it back to its original position. If this words or this paragraph was there, then you could have marked option A. How many of you got it? Give me a thumbs up or a heart emoji in the chat box right away, right now. Yeah. All right. Very good. No, Likita, Madan sir is not a part of Vedantu anymore. Yeah. Okay. Great. Amazing. Amazing. So it's time now to go to the next question coming up on your screen. So let's see what it is. Let's see. Property that the force with which two charges attract or repel each other are not affected by the presence of a third charge. Force on any charge due to number of other charges is the vector sum of all the forces on that charge due to the other charges taken one at a time. Very interesting question. It is based on nothing but what? The superpositioning principle, the property that the force with which the two charges will attract or repel each other are not affected by the presence of a third charge. Yeah, that is definitely, true. This is principle of superpositioning. Force on any other charge due to number of other charges is the vector sum of all the forces on that charge due to other charges taken one at a time. That is also true. But how is this explaining this? Please think. Okay, if you're not able to realize which option should I choose, A or B, because both are correct right now, this is when the most of the confusion happens. Say both these statements in your mind aloud with the word in between, which is because, or due to, or something like that. So the property that the force between the two charges which attract or repel are not affected by the presence of a third charge, because the force on any charge due to number of other charges is the vector sum of all the other forces taken one at a time. I don't think so it is explaining it. So it should be basically option B. No, it is not A, it is option B. Everyone? Yep. Is that absolutely clear? Do let me know quickly in the chat box, my dear warriors. Yeah, it is not explaining. I mean, there is no reason actually why, two charges will attract each other independent of the other. I mean, that is the whole point of superpositioning principle. It just happens. We do not know why it happens, but it just happens. So the third charge will not affect it. So that is principle of superpositioning. Yeah. So like I said, Anbu, always try to put a word because. So put a word because. The property by which the two charges will apply forces will not be affected by a third charge, because the net force is the vector sum of all the forces taken one at a time. How? Why is it the third charge not affecting it? Is it because the force is a vector sum? Doesn't make sense. Actually, the reason should have been because of the superpositioning principle, which says that the vector sum is what the net force is and the forces are independent of each other. If that word independent superpositioning principle would have been there, then that reasoning would be the correct explanation. Got it? Everyone? Right. Let's go to the next part, which is electric dipole. Dipole. Di means two, poles means polarities. In electricity, we have two polarities, positive, negative. So two equal and opposite charges close by enough to each other, that constitutes an electric dipole. But please keep in mind, they have to be equal in magnitude charge wise. If this is 5 coulombs, this should be minus 5 coulomb. If this is 7 coulomb, this charge should be negative 7 coulomb. So 3 coulombs and negative 5 coulombs will not make up a dipole. Got it? So equal and opposite charges close by enough is called as electric dipole, and the dipole moment is a vector quantity which tells me how strong that dipole is. So it is the charge multiplied by the length of separation between the two charges. So keep that in mind like that. So if you have a negative charge and if you have a positive charge and if you have some kind of separation between them, then the electric dipole moment is always from negative to positive. Please keep that in mind. So this is your dipole moment, and that dipole moment is nothing but any one of the charge, any one of the charge, you take any one of the charge magnitude wise, any one of the charge magnitude wise, multiplied by the separation, multiplied by the separation. That separation always from negative to positive is taken as the direction of that vector. Okay, so whatever that separation is, 2x, 2l, 2a, 2d, whatever, or x, l, 5 meters, 20 meters, whatever it is. So that is what will give me the dipole moment. The unit, what will be the unit of this? What will be the unit, SI unit of dipole moment? Yeah, this is coulomb and this is meter. So coulomb meter is the SI unit of a dipole moment. So if you show this kind of a diagram, if you mention this and the formula, 100% you will get that marks. Okay, you have to mention the direction also and mention it is a vector quantity unit formula diagram. Done, sorted. Dipole in a uniform field, that is the next part. What happens when you take a electric dipole and put it in a uniform electric field? Each charge will experience a force, but since both the charges are opposite, the forces will also be opposite. Hence, the net force on it will be always zero. But the torque will not be zero because the forces may not exactly be along the same line. So, they will create a kind of a torque. So, you can show it in the form of a diagram also. Say for example, this is your electric dipole, this is your negative charge, this is your positive charge, and let's say this is how your electric field is, this is how your electric field vector is. Then on the positive charge, the force will be in the same direction as the field. On the negative charge, it will be exactly opposite. So this is F negative and this is force on the positive charge. So if you calculate the net force, if you calculate the net force, it will be the force on the positive charge plus force on the negative charge, which will be obviously zero because they are equal and opposite. They will cancel out each other. So this is always zero. It will always zero. Okay. The net force on that will always be zero, but the torque will be there. The torque will be there. You can see this is producing a kind of a torque. This is producing a kind of a torque over here because the forces are not on that same line. If the forces were like this, then the torque will not be there. But the moment the forces are separated by some distance, there will be a coupled torque. So coupled torque, when two equal and opposite forces are not along the same line, that creates a torque which is called as a couple. So it's called as a coupled torque. So that coupled torque is definitely going to be there, and that coupled torque is nothing but what? The dipole moment is nothing but the dipole moment is nothing but the dipole moment vector cross producted with, yes, this coupled torque is a vector quantity, cross product it with what? Exactly, yes, you have to cross product it with the electric field, with the external electric field, external electric field vector. So P cross E will be the torque. The dipole moment cross the electric field will give me the net torque acting on it. When will this torque be zero? Think about it. When the charges are perfectly aligned with the field. Like for example, in this scenario, imagine the charges are perfectly aligned like this, minus over here, plus over here, and the electric field line is passing like this. Then you will see that in such a scenario, the torque acting on it will be zero. Okay, this is a kind of an equilibrium situation. So when the dipole moment and the fields are aligned, then you will see there will be no net torque only in that special scenario. Other scenarios, when it is making an angle, obviously there will be a torque acting on it. Having said that, yeah, the magnitude is basically PE sine theta. So there are two situations when the torque will be zero. One, when it is 0 degree, or another is 180 degree. So torque is zero when sine theta is zero. Sine theta is zero when theta is 0 or 180. When is the torque maximum? when theta is 90, because sine of 90 degrees is 1. So when it is perpendicular, the field is perpendicular to the dipole moment, then the torque will be maximum, because sine's maximum value is 1 when theta is 90 degree. Okay, everybody fine till this point? Yes, very good. Net. So what happens if net force on the torque and couple? What happens if net force on torque and I'm not really sure what you're asking, Jai Krishna. Can you be more specific? I didn't really get your question. Yeah. All right. Potential energy wise, the formula is minus PE cos theta. Very, very important. Negative P vector dot E vector. That is the energy stored. So the lowest energy is when theta is 0, because cos 0 is 1. So negative P will be the lowest energy. But when theta is 180 degree, so dipole moment is opposite to the electric field, then cos 180 is negative 1. Negative 1 into negative will make it positive. So positive value means highest value. So when theta is 180, then you will see highest potential energy. That will be unstable. High energy is unstable, low energy is stable. Keep that in mind. So negative P dot E dot product will make it potential energy. You put cross product without the negative sign, that will give you the torque acting on it. Very straightforward. Yeah. So let's have a look at some of the questions coming up on your screen. Here it is. An electric dipole of certain length is placed, and the question is you have to figure out that if the field is this much, the torque is this much, what is the magnitude of the charge on either of the dipole. So start off by writing down the formula. The torque magnitude is given by the dipole moment multiplied by the field magnitude and into sine of the angle between them. Okay. Is the angle given? Yes. Dipole moment, we can find out, from that we can find the charge. So the torque given is nothing but 8 multiplied by 10 to the power 3. Dipole moment, I do not know. We can do one thing though, before doing that. The dipole moment is itself nothing but the charge multiplied by the separation. Charge multiplied by the separation, and the field will come, and theta value is nothing but 30 degrees. So sine 30 is the torque. Oh, so now we can start substituting one by one. First of all, the torque is 8 multiplied by 10 to the power 3. Charge I do not know. Separation is 2 centimeters. That means 2 into 10 to the power minus 2. What is the electric field? 2 into 10 to the power 5. Sine 30 is nothing but half. Show these steps and show the cancellation part also. Like this 2 and this 2 will get cancelled maybe. You can cancel this 2 with this 8. It will become 4, right? And this minus 2 and 5 will become 3. This part 10 to the power 3 and this 10 to the power 3 will also cancel. So I am just left with over here 4 is equal to Q. Yeah, but have we missed anything else? 2 centimeters. Yes, that is also done. Electric field 2 into Newton Coulomb. Okay. Newton meter. Yes, everything else is fair enough. Yeah, minus 2. Okay, so Q is equal to 4. So I think maybe one of the powers were slightly different than what is given over here. Maybe it was millimeters or something else, or the powers were slightly different. But Q is coming out to be 4 coulombs over here, as I can see. Yeah, just check. Our calculations are fine. The torque is 8 into 10 to the power 3. Separation is 2 centimeters. So 2 into 10 to the power negative 2. So this was 2 into 10 to the power 5. So 5 minus 2 is 3. 10 to the power 3, 10 to the power 3 cancels. So charge is equal to 4 coulombs. So I think that milli was not there. Yeah, most likely that milli was not there, or micro was not there. Maybe that's a printing mistake. Okay. So I'm just going to remove that. So this is the right answer, unless the powers were slightly different. So now obviously we can say option number A is the right answer. Is that okay? So show all these steps, definitely you will get the full marks. Let's go to the next one coming up on your screen, and here it is. Depict the orientation of the dipole in stable and unstable equilibrium in a uniform electric field. Very, very important. Depending on the marks, you will add more lines or remove more lines. Yeah, very simple. So guys, in stable, what will be the angle between the dipole and the electric field? Stable means less energy. Less energy means negative P. Negative P will happen when theta is 0. Cos theta will be 1 then. So this is that scenario of stable equilibrium when theta is 0. When dipole moment, you can see, is exactly parallel to the electric field, but it will be an unstable situation when theta is 180. That means the dipole moment is opposite to the electric field. If you want, you can mention in both the scenarios that because theta is 0 or 180, torque will anyways be 0, because it will be P E sine 0, which is a 0. Here also torque will be P E sine 180. Sine of 180 is also 0. So it's in equilibrium. But what is not 0 is the energy. Here energy will be minus P E cos 0, which will be minus P, which is the minimum energy. And here energy will be minus Pe cos 180. Cos 180 is minus 1, so it will become plus P, which is basically the maximum energy, which makes the equilibrium unstable. So if you show all these things, it's an added advantage. You will definitely get better marks. Yeah, very good, Ambu. All right, all right. Very nice. You got 82. Why you are saying 98, Ganola? Is there a specific reason why you're saying 98 and not 99 or 100 or 97? 82 is a good score at this point of time. Easily you can reach 90, but reaching 95 will require a lot of hard work, lot of strategic, I would say, tackling of those problems and, the questions. So you'll have to go deeper if you want to go above 95, especially in physics, assuming the same level of paper comes in 2026 as of 2025. So the paper was of decent level. So if you get good questions, your timing, your selection of questions, your derivations also matter, your problems are also slightly lengthier, bigger. Okay, assertion, reason, you should not get confused. So all these things together, definitely you can reach 95 plus. Moving on, moving on to the next question on your screen. Here it is. Let's see if you can solve this. Okay, ready for this, my dear warriors? Okay. There is a dipole of 4 centimeters length when placed in the axis of 60 degrees with a field experiences a torque of this much. Find the energy it has if the charges are plus minus 8 nano. Nano is 10 to the power negative 9 coulombs. Okay. So torque is given, energy is asked. Angle is also given. Great. So how do we exactly do this? I feel for this particular question, rather than substituting and getting the answer first, I'll first see how the torque and energy are related, and then I will substitute in the end because I want to minimize my calculations. Okay, so let's do this. Torque is given to me, and we know torque magnitude wise is Pe into sine of theta. Similarly, we also know energy is nothing but minus Pe cos of theta. Looking at both of them, are you tempted of doing something? I know torque, I want to find energy, and I also know theta. I just do not know P and E right now. At least electric field is not given. So I think you should be tempted to divide both of them, isn't it? So mention this. So mention this. Dividing. Divide both of them and see what do we exactly get. So U by tau, potential energy by torque, will be minus Pe cos theta divided by Pe sine of theta. Obviously, you can see Ppe will get cancelled, and over here we have U. I can take torque on the other side, and also negative sign will be there. So negative of torque, and sine theta by cos theta is nothing but tan of theta. So torque has gone on the top, sine by cos is tan in the denominator, negative sign is there. I don't need the value of P nor of E. Now it becomes a straightforward question. As you can see, energy will be negative of torque And the torque value, where is it given? 4 root 3. Perfecto. By tan of theta, that means tan of 60 degree. What is tan of 60? Tan 60 is root 3. Root 3 will cancel and I will get the answer as minus 4 joules. Everything is SI units. Is that right? So such a nice, elegant, simple solution it has, and you don't have to find the value of P and E. Yeah, minus 4. If you miss the negative sign, you will not get full marks. Maybe you will get some step marking till here, but don't expect, you will get full 2 marks or 3 marks. You will definitely lose 1 mark at least. Or maybe examiner is in a bad mood. You don't know, right? Unless the paper goes for rechecking then. Okay, let's go to the next concept of Gauss law. Gauss law is used to figure out the electric field of symmetrical bodies in a much easier way without actually complicating and finding it via some complex integration. Okay, so Gauss law is based on the concept of electric flux. An electric flux is a scalar quantity which quantifies how much field is passing and piercing through any imaginary or real area. So if more field is concentrated in an area and passing through it, then it has more flux. But if the field lines do not pass through it, it has no flux absolutely. Imagine a surface like this and the field lines just pass over it or below it, then it has no flux. At the moment the field lines pass through it, it has some flux. And the flux can be positive or negative depending on the direction in which they are entering or exiting. So if you have a surface which is closed, like say a balloon or a cube or a cylinder or a cone, if the electric field lines are exiting out of the closed surface, it is considered as a positive flux. But if they are entering inside that closed surface, it is considered as negative flux. So positive is exiting because positive charge will give away the field, negative charge will terminate the fields. So you can imagine field lines terminating. So negative flux is when they enter inside a closed surface. So the Gauss law says that the electric flux of a closed surface is proportional to the charge which is inside of it, and it is given by charge by epsilon naught. So the diagram for that, very, very important, guys. So say for example, you show some charges like Q1, Q2, maybe negative, maybe Q3, maybe negative, maybe Q4, maybe positive. Okay, then maybe Q5, then Q6, maybe negative, maybe Q7, maybe Q8, like that. And you imagine some kind of a Gaussian surface like this. Gaussian surface means any closed surface. This is Gaussian surface, Gaussian surface, Gaussian surface. And at every point, there will be some kind of electric field. Maybe the electric field at this particular point is, let's say, E. Okay. Maybe at this particular point, it will be here. Maybe at this point, it will be here. I don't know. But you must just assume something. Okay. So this is the electric field at any point. And at this particular point, you will also see that on the surface, there will be a small area vector. I can call it as ds bar. This is a small element of area. So you need to mention all of this. ds is nothing but elemental area on that surface, and E is the electric field at that particular point. E is the electric field at that particular point. Then electric flux for the closed surface, electric flux for the closed surface, for that closed surface or Gaussian surface is nothing but you take electric field at every point and do a dot product with the area vector at that place, and you basically have to integrate it over the entire surface. So that's why you put this integration symbol with a circle or a dot over it. This is called as a closed surface integral. That means you need to consider the entire surface. Don't even leave a little bit of area. That is the symbolic meaning of it. And then when you actually calculate it, this comes out as the charge inside by epsilon naught. Charge inside by epsilon naught. So the charge which is inside is only these four charges. These four are outside. So it will be just Q1 minus Q2, in this case minus Q3 and Q4. That's it. That's how you apply Gauss's theorem or Gauss's law. Only the charges inside contribute in the flux. Outside charges do not contribute in the total flux. That's it. Is that okay, everyone? Yeah? Perfecto. Yeah. Yeah. Great. Great. Amazing. Amazing. All right. So these are the formulas which you should keep in mind. And next thing, the applications of Gauss law is preferably for, yeah, they can give you a question. Explain Gauss law and where is it used or how is it applied, or discuss about it or something like that. Then it is first of all very important that you use it for symmetrical bodies where the electric field is either perpendicular or parallel to the surface, so that the calculations become easy. Because when angle is 90 degree, cos 90 is 0, and when angle is 0, then cos 0 is 1. So the calculations are simpler. It is also valid only for closed surfaces, and you can also mention that only the inside charge will decide the total flux. Outside charges do not decide the total flux. You can mention that. Okay. So the formulas which are going to be derived with this particular theorem, by the way, the derivation I have already done. You can check out these derivation sessions. It's there on the Vedanta JEE English channel. Please subscribe, because this is not the only session. There are more sessions which are lined up. And last year we had conducted marathons. Those marathons are also there in a special section dedicated just for NCERT preparation, including English, guys. So English, physics, chemistry, maths, and there will be more sessions for English also this year. Okay. Yeah. So you can watch this session. All important sessions are there right over here. All right. Very good. Excellent day. So for a sphere, which is charged, inside there is no charge, so field is 0. But outside the field is just like a point charge. It is Coulomb constant Q divided by R square. If it is a line charge, then it is lambda. Lambda is charge per unit length. So divided by 2 pi epsilon naught r, not r square. Be careful, it is not r squared, it is r only. If it is a long wire which is charged like this, and you want to find the field at any given point from that charged wire, lambda is how much charge is there per unit length, also known as linear charge density. If you have a sheet, okay, imagine a sheet like this, it is charged uniformly, and you know a quantity called sigma, which is how much charge is there per unit meter square, then the field is uniform. It goes this side also and this side also, and it is uniform. That means constant. It is sigma by 2 permittivity constant, 2 into epsilon naught. If you have a charged thin shell also, it's the same thing as a uniformly charged sphere, because whether you have a shell, that means hollow sphere, or a solid sphere, the charges for a conducting sphere are always going to lie on the periphery. So conducting sphere behaves like a shell only. That is a unique property of a conductor, because the charges only reside on the surface of a conductor because they repel in a conductor. But only for an insulator, they can be embedded inside, because insulator does not allow the movement of charges. Keep that in mind. So you should pay attention to that word, whether it was conducting or non-conducting in nature, right? So let's see a question coming up on your screen, and here it is, guys. Okay. All right, I will just inform Rangampeta. Just put up a message on the comment section. I will definitely get it sorted if there was no PDF. All right, not an issue. All right, so let's see, guys. A question coming up on your screen. There is a square sheet which is lying parallel to the XY plane at Z is equal to A, the field in the region is given by CZ square K cap, the flux through the sheet is how much basically? That is the question. Okay. So we have to calculate the flux passing through the sheet, and the field is also not going to be constant, and you have to figure out what is the total flux through that particular sheet. All right. So let's draw the diagram so that we get an idea. This is y-axis. This is our x-axis, and maybe this is our z-axis right over here. Okay, so this is x, this is y, and this is z. Square sheet of side is lying parallel to the xy plane at z equals to a. So z equals to a means somewhere over here. So our sheet is right over here, something like this. This point over here is basically z equals to a. So it's parallel to the xy plane. Visualize it. Okay, just visualize it. And the square side length is given to be a. So this is a and this is also a. Okay, great. The electric field is towards us k cap, that means z axis, and it is cz square. So the electric field will be towards us and maybe like this. Like this. And what might be the value of the electric field at this particular region? Z value is already A on this entire plane. Just visualize this plane, guys. Just visualize this plane. It is parallel to the XY plane and it is slightly offset by an distance of A. It is in front slightly. So Z coordinate everywhere will be A. So hence the electric field will be C into A square K cap. Yeah, C into A square K cap Newton per coulomb. Is that right? So now when we have to find the electric flux, flux, either you integrate or you just see whether the field is uniform. In this entire region, the field is constant. In this entire region, the field is basically a constant on the sheet. So when it is constant, I don't have to actually perform integration. I can just say it is electric field dot the area vector. I don't have to put dA and integrating it, not needed. I can just say it is dot producted with area vector. Now, where is that area vector? Well, the area vector is also towards this side, and the area vector in magnitude will be A into A, which is A square, and this is nothing but K cap. So it is A square K cap. So I'm just going to put A square and K cap like this. In the electric field vector, we just got it right over here. How much is that electric field, guys? It is nothing but C A square, and that is also going to be in K cap. Perfect. So now you just have to do the dot product of both of them. K cap into K cap is 1. So this will become C A square multiplied by A square. K cap into K cap is, remember, always 1. So this is C A raised to 4. This is your flux. C A raised to 4. That's it. Got it? Very good. What are the units of electric flux? Well, here we don't need because nothing was given in the units. But if at all it was asked, then it will be Newton per coulomb into meter square. Yeah, if the units were required, Newton per coulomb into meter square. Newton per coulomb for our field, area is meter square. Simple. Okay, perfect. Awesomeness, guys. Let's go to the next question coming up on your screen, and here it is. This was asked in the one of the previous years. Okay, this is a proper reasoning based question. See how the question can be asked. There are, I think, two shells, S1 and S2, or spheres, which have charges of 2q and 4q enclosed respectively. And so sphere 1 has charge of 2q, sphere number 2 has a charge of 4q. Find out the ratio of the flux through them. That means how much flux will pass through the spheres or those shells. And what will be the flux if the medium between S1 and S2 is filled with a dielectric in place of air. Okay, let's try to understand that. Okay, let's solve both the questions one by one. Let's solve both the questions one by one. For the first scenario, see, I'll tell you what. The inner sphere, sphere number 1, has a charge of plus 2q. So when you try to find the flux to the first sphere, it is the charge through that, which is 2q, divided by epsilon naught. Now when you try, okay, the outer sphere has a charge of basically 4q. So the total flux through the second sphere will be not just 4q, this is the common mistake which many kids did, plus the 2q, because that is also going to be there inside, guys. Yes, that is also going to be there inside. So now when you actually try to find out the answer of flux in 1 upon flux in 2, it will be nothing but 2q by epsilon naught. 4 plus 2 is 6, so 6q by epsilon naught. Epsilon and q will cancel and you will be left with 1 by 3. So the ratio will be, for the first answer, it will be 1 by 3. Is that absolutely clear? Because for the outer sphere, not just that charge, but even the inner sphere's charge will be counted, because both of them are internal charges, inside charges. Now for the second part, what happens if you place some kind of a dielectric medium in between? So just imagine somebody places some kind of a medium over here, some kind of a medium here, and I am being asked, figure out how much flux will pass through this part. How much flux will pass through this particular part, somewhere in between both those spheres. The inner sphere, like we understand over here also, the inner sphere has a charge of plus 2q. The outer sphere has a charge of plus 4q. So when I find the flux from that closed surface, when I find the flux from that closed surface, which is in between both those shells, it will be whatever charge is inside by the permittivity, but that permittivity will no longer be epsilon naught, it will be epsilon naught into epsilon r, which is the relative permittivity. This is the relative permittivity. This is the relative permittivity. So you need to consider both of them, and hence then the answer will be, nothing but, what will you get? What is the charge inside? Only 2q is there. So 2q by epsilon naught into epsilon r. 2q divided by epsilon naught into epsilon r. Yeah? Perfect. Amazing. Let's go, guys, to the next question, which is asked many times. If you want to find out the field due to a long wire or due to a charge sheet, what kind of surface will you take when you apply Gauss law? This is a part of derivation. So guys, if there is a long wire, then you will choose the surface which is cylindrical in nature, because the field will come out like this. So on the curved surface, you will see that the field will be perpendicular to the surface, which makes the calculations easier, right? And if it is a charge sheet, also you can take a cylinder which passes through the sheet, because the sheet will give electric field lines like this. So through the flat surface, again when they pass, it will be perpendicular on either side. So you have to show this diagram for both the sheet or for the linear charge. They are both cylinders, but how they are arranged and why you have taken, that is also important. Okay, so this is also very commonly asked. Great. You can also take a rectangular composition over here. Rectangular sheet is also, rectangular shape is also possible. There is no need that you have to always take a cylinder in this case. Cylinder is necessary for this one. Here, even if you take a cuboid-like structure which pierces through it, it's good enough. As long as it is a symmetric body which is on both sides, right? Okay, perfect. Let's go to the next point, which is the concept of electric potential energy of charge systems and bodies. Okay, let's go. Yeah. Yes. Rectangular parallelepiped. Yes, you can use that crystalline. Perfect. Arvinda, Is that so? I will definitely make a video on that as well. Thank you for pointing it out. Electric potential and potential energy of a charge system. Electric potential is nothing but how much work is done to bring some charge from a very far away place, that is infinity, to a specific point. So if I do 10 joules of work to bring 2 coulombs of charge from a very far away place to a specific point, so I have done 10 joules per 2 coulombs. So per coulomb I will do 5 joules. So 5 volts is the voltage or the potential of that point. So that is how it has been defined, and that can be also calculated. You don't have to every time calculate work and divide it by the charge. The formula is Coulomb constant Q divided by R. So if I know how much charge is there and I want to find at this point how much is the potential, you take this formula, substitute the charge, substitute the distance where you want to find the voltage or potential, you will get the points voltage. Okay, it's a scalar quantity because it is energy per charge. Okay, it's not a vector, it's not having any direction. The SI unit will be volts, and volts is nothing but a joule per coulomb. So a volt is nothing but a joule of work per coulomb. Okay, keep that in mind. It comes from the definition only. How many joules of work will you do per unit coulomb of charge in bringing it at a specific point is defined as the voltage of that point. Now, if you bring a charge at one point and if you bring the same charge at some other point, different work will be done. So they will definitely have different voltages. So this point has 2 volts, this point has 7 volts. So there is a voltage difference. 7 minus 2 will give me 5. That is called as the potential difference or the voltage difference. So it's just simply the difference of the voltages of 2 separate points which might have different works per unit charge. Now, when you move that charge from one point to the other, some work might have to be done. So, how much work is done to move that is given by charge into the voltage difference. We'll come to that in a bit. I'll give you a very specific formula which will be very useful. Hold on for that. Now, imagine due to this charge there is a voltage, due to another charge there is a voltage, due to third or fourth charge there is a voltage. So the total voltage is simply the scalar sum, yeah, not vector because they are all scalars. So scalar sum of each and every single voltage, that will give me the total voltage. Please remember, positive charges will give positive voltage, negative charges will give negative voltage. So when you are adding them up, don't just take the magnitudes, take the sign also along with it. Okay, it's very easy to add potentials because you don't have to break your head which direction is the voltage coming from. You just need to add the voltages very simply, just like you add numbers 2 plus 3 minus 5 minus 7 plus 7 plus 8, like that. That's it. Cool. Now, when there is potential, there is also energy associated if you place a charge over there. See, if you have a charge at a point, there is potential. That means ability to gain energy. Right now, it does not have energy. It just have potential. Like you have potential to score marks in CBSE board. But when you actually conquer it, when you actually write the paper, that's when you get those marks. Same way, when you actually put a charge at a place, that's when it has potential energy. So the potential energy is nothing but, the Coulomb constant Q1, Q2 by the distance. Same formula, just add one more charge on the numerator side. So Coulomb constant Q1, Q2 by R is the energy of that two particle system. But sir, what to do if there are so many particles? Then you take each pair, Q1 with this with this, this with this with this with this, form all sorts of pairs and you add them up. That will give you the total potential energy. Is that right? Okay. Now, I was just mentioning that I'll tell you one specific interesting formula. Observe this carefully, guys. Imagine this is my initial point, and at this point, the potential is 1. And I go to some place over here. The potential over here is 2. And in this process, I am taking this particular charge like this. Okay, I'm moving this charge like this. So, there are a couple of things. First is potential difference. Potential difference is always final minus initial. So V2 minus V1 Always keep in mind final place, destination minus the initial starting place. That is the potential difference. Number two, if you multiply the charge with the voltage difference, what you get is the energy difference. So, potential energy difference. Potential energy difference. Potential energy difference is the charge multiplied by the voltage difference. So this is 2 coulombs, this voltage is 7 volts, 2 into 7 will be 14. So 14 joules of energy difference will be there when you take the charge from here to here. Energy wise, how much difference is there associated with the charge? From that, you can calculate the work done. Now, this work is of two types. Work done by external force is how much? That is exactly going to be delta U. But keep in mind, it is also negative of the work done by electric force. So read the question very carefully. There is a beautiful NCERT question on that. How much is work done by electric force, or how much is the work done by external force? So both of them magnitude wise are same, but sign wise they are going to be different. They are going to be different. So this is the formula, guys. Keep that in mind. Okay. If you want, I can take up a simple question on it so that you guys understand. Imagine there is a point here. This is my initial point. This is my initial point, which has a voltage of, let's say, minus 10 volts. And there is a point over here, final point, which has a voltage of, let's say, plus 30 volts. Chumma, I have taken some random places. And then what I have done is I have moved some charge of minus 2 coulombs along this path like this. So the question is to find everything like delta U, delta V, work done by external, work done by electrostatic, everything. So let's calculate it one by one. Delta U. Oh, sorry. First, delta V will calculate voltage difference. So voltage difference is final, which is 30, minus initial, which is negative 10. So it is going to be 40 volts. That's it. Next, what is the energy difference? It is the charge, which is in this case minus 2, multiplied by the voltage difference, which is, sorry, which is nothing but plus 40. So hence, the answer for that will be minus 80 joules. So the energy has decreased. Minus means energy has decreased when you move this negative charge from here to here. Next, the question can be, what is the work done by my external force moving that charge? It will be exactly delta U. So it will be nothing but minus 80 joules only. If the work done by electric force is asked, it will be negative of whatever answer I got over here. Hence, electric force has done 80 joules of positive work. So I'm using this particular formula. So if you know this slide, it becomes very easy to calculate any sort of question, any sort of sign, any sort of displacement. Is this example making it very, very clear? Yeah? Yeah. Arivasu, it is announcement is coming in the first week of November. Everything will start in November, guys. Okay? Yeah. Awesome. Awesome. Perfecto. Any doubts still here? Shall we go ahead? Yeah. Very good. Last thing, we can also figure out electric field and voltage relationship. Remember, electric field is nothing but negative of rate of change of voltage with distance. Rate of change of voltage with respect to the distance. With respect to the distance. So electric field is minus dV by dr. Very, very important. This formula also very useful in many places. Whether it is moving with X or Y or Z, you can use this. Okay. So these are all the important points which are over here. Maybe we can start solving some questions coming up on your screen. Here it is. If the electric potential is given by 3x square volt, then the electric field at 103 will be how much? Electric field will be how much? First of all, observe carefully. This voltage is only changing in x-axis. So the field will also be in x-axis only. There is no question of y or even z. So if there is something which is related to y or z, first of all, ignore it. But luckily, nothing is in y or z. So great. So the electric field in total will be just the electric field in the x direction, which will be negative rate of change of the voltage with respect to x only. So everything is in x, so that's why. So d by dx of 3x square, 3 is a constant, so comes outside. Derivative of square of x is 2 of x. So it will be minus 6x. But I need to substitute the value of x, and the value of x to be substituted will be this one. This is my value of x. So I'll just put 1 over here. So this will become minus 6, but this will be volts. So the electric field is minus 6 volts, meaning the electric field is in this direction of 6 volts. Sorry, 6 volts per meter, my bad, 6 volts per meter. So the electric field is 6 volts per meter opposite to the direction of x. Yeah, it is 6 volt per meter along the negative x direction. So option D is the right answer. Very good, excellente. Many of you got it. Good evening, Tirtheswara. Welcome aboard, everyone. Shall we go to the next question, guys? Shall we go to the next question coming up on your screen? Ready for it? Yeah, here it comes. See, what does it say? 4 charges are there. They are placed on the corners of a square whose side length is 2L. The potential at point A is asked, which is midway between the charges small q over here. This is minus q. Very interesting question. Let's see how do we exactly solve it. Now, the potential of this at this point is asked due to this point, this point, this point, and this point. How far are these points? Let's see. This is this far, this is this far, this is this far, and this is this far. Oh, so I need to know the distances, only then we can calculate. So if you ask me the distance between the positive charge and A, so the distance of plus q and the point A, it is exactly the midpoint. So whatever is the side length, whole thing divided by 2. So the side length is how much? 2L. So it will be 2L divided by 2. That means it will be L. Very straightforward. Between negative q and A, so the distance of minus q and A is given by Pythagoras theorem, I believe, because if you observe carefully, you will realize it. Yeah, this base which I can form over here in this small triangle, yeah, this base is the side length, and that side length is basically 2L. This is half of the side length, so it will be L. This is what I want, which is the hypotenuse, in this triangle. So hypotenuse by Pythagoras theorem is given by 2L square plus L square. So it will become nothing but 4L square plus L square. So L comes outside, root of 5. 4 plus 1 is 5. So L root of 5. Once these distances are done, we can now figure out what is the potential at point A. It will be potential due to positive charge, but that will come 2 times, plus potential due to the negative charge. Because of the symmetry, that will again come 2 times. So due to the positive charge, what's the formula? 1 by 4 pi epsilon naught multiplied by charge, which is q, divided by distance, which is L, but 2 times. This negative charge will give negative voltage, so minus sign. So 1 by 4 pi epsilon naught, that negative charge has already been taken into consideration. L root 5 kq by r formula, and the whole thing into 2. That's it. So from this, you can see a lot of things are common, obviously, like 2q divided by 4 pi epsilon naught L is common. And over here, we will have the number 1, and over here we will have the number 1 by root of 5. 1 by root of 5, which will give the answer as option C. Got it? Very straightforward if you do step by step. Hi Nikisha, life means Greek, everyone. Got it? Namaste, Panubar, smart. I'm so glad that you are watching the class, and you should continue watching the classes, because not just this is the number 1 J English channel, you have all the amazing content for J 26, 27 plus CBSE. We have a separate section which I just showed it to you sometime back right over here. Okay, so let's move, guys, to the next concept. Let's, guys, move to the next concept coming up on your screen. Ready for it? Equipotential surfaces. Equipotential, like the name suggests, equal potentials. So if I have many charges, they generate potentials. If I see all those points which have same voltages, and if I join them, that becomes an equipotential surface, line, whatever. So it's nothing but a collection of points with the same voltage. It's an imaginary thing again, okay? And if you draw a tangent or rather a perpendicular to it, or a perpendicular to the tangent, that gives me the electric field at that location. So let me explain this. Imagine I see all these points somewhere are having the same voltage, so I'll call it V1. I see all these points over here have same voltage, I'll call it V2. I see all these points have same voltage, I call it V3. All these are equipotential surfaces. Now, if you draw perpendicular to any point, let's say over here, then that gives me the direction of the electric field. So the electric field will be always perpendicular to it. And here also maybe the electric field line will go like this and maybe like this. So this is how the electric field lines will travel. Always the electric field is perpendicular to the equipotential surface or line. It is always perpendicular to the equipotential surface or line. And this electric field will always go from high voltage to low voltage. High potential to low potential. It will always fall down. It will never go up. It will always go towards the lower potential. Keep that in mind. Okay. So certain important points. These are imaginary lines. They tell me how strong the surfaces are, fields are, or how strong the potentials are. They are nothing but imaginary lines at the end of the day. Electric field lines are always perpendicular to my equipotential surfaces. And if the electric fields, let's say, are concentrated, electric fields are concentrated at a point, that means the field is strong. If they are far away, that means it is weak. Okay. And if you have an electric field line, if you draw a tangent at any point, then the tangent drawn gives me the direction of the force acting on it for that particular field. Okay, so the tangent drawn gives me the direction of the force acting at that particular point. No two electric field lines can ever intersect, because then it will mean it has two forces or two tangents, which is impossible. Keep that in mind. Okay, so having said that, we can also say that electric field lines always will start from a positive charge and end at a negative charge. Yeah, they will always originate from a positive charge, they terminate on a negative charge. All these are standard things regarding electric field lines. They can't intersect. Closer lines means strong, wide means weak. Uniform field, the lines are parallel. Non-uniform, they are going to be random, like over here. They are non-uniform. That means it is not constant in strength. If it is uniform, they will all be parallel, like for a sheet. If you take a charge sheet, the field lines are parallel to each other. So the strength will not change no matter how far or close you are. Okay. Closed loops are not there. Yes, closed loops means it's not like the field lines are like this. The electric field will always start and end at some point. It will start from positive and end at negative. Great. Cool. So for positive charge, how does the field look like? It looks like radially outwards. Radially outwards. If you take a negative charge, how does it look like? Then it is radially inwards. If you take a dipole, that means positive charge and then a negative charge, then how does the field lines look like? They start from positive, go to negative, start from positive, go to negative, and it is completely symmetric. This is how it looks like. Okay. Yes. This is how the electric field lines will look like for a electric dipole. This is the plan. Cool. Let's see some questions based on this. We have this particular question. Which of the following diagrams represents the electric field between two charges or two charge plates if a neutral conductor is placed in between the plates? Interesting. So there are two charge plates, positive and negative. In between them, you have placed some neutral conducting body. So think like this. You have one which is positive, one which is negative, and then in between of them, you have placed a neutral conductor. How do you think it will behave? Keep in mind, whenever you have a conducting surface, if this is a conducting surface, conducting surface, the charges always reside on the surface. Not just that, the electric field lines, the electric field lines everywhere, they are going to be perpendicular to the surface, and electric field inside is going to be zero. Electric field outside is going to be non-zero, and it will be there which is perpendicular to the surface, but inside there is nothing. Same thing should be observed here. It should be perpendicular no matter what. Everything is a conductor. So I don't think this is possible. This doesn't seem possible because the electric fields are moving away. This or this, they both look perpendicular, but one of them is right. What do you think is the right answer? Okay. Pritija, if you are interested in such kind of a job, please, I would love to hear from you. You can send me a LinkedIn request and also your profile. I will definitely consider you for internship because definitely we do take students who would love to earn money as a part-time and are dedicated towards not just their studies but also to their work and want to earn some money. So definitely you can send me your resume and what kind of work you can do. You just send me a LinkedIn request. You have a LinkedIn profile, or else just send it to me on Telegram, Captain_Shreyas or Captain Shreyas. You can find it. Yeah. So what do you think, guys? Yep. So it has to be D option because they always should start from positive. Why will the field lines be like this? Because now it is not 90°. It has to be always perpendicular no matter what. And it should terminate on the negative charge, and even on the conducting surface, it should be perpendicular. It's a spherical body. Wherever it touches it, it should be perpendicular. So yes, it should be D option only. Yeah. This property should be obeyed. Yeah, it cannot violate this property. Make sense, everyone? Great. Let's go to capacitors now. Capacitors. Please remember that this is one of the biggest units. Electrostatics, capacitance, Gauss law. So that's why many questions and many subtopics are there. Don't think that, sir, you are teaching this so slowly or what. No, many subtopics are from the first two chapters. They are really high weightage, still current electricity. Yeah. Very good. You are correct. Yes. The duration will be around 4 to 5 hours, man. Yeah, already we are done almost 2 hours of this, and we are barely 1/3 of the session, I feel, or barely, I'm saying. Okay, cool. Chalo, let's go then. Let's go. Yeah. So if we have done 1/3 and we are done 2 hours, so oh my God, don't tell me then it will be 5 hours easily. So let's see how do we solve this next thing and the concepts. Capacitors. Capacitor is a device which can store the energy on the conductors when the charges are separated on those conductors, and it creates a voltage difference. So the capacitance of a capacitor, how much charge it can hold per unit voltage. Capacitance of a capacitor, capital C, is how much charge it can hold per unit voltage is Q by V, or Q is C into V. The unit is farad, and a farad is nothing but how many coulombs of charge can you store per unit volt? How much coulomb of charge you can store per unit volts. That is what it is. It's ability of a system to store charge per unit potential difference. And the symbol of a capacitor we know is like this. The total charge on a capacitor is zero because each conducting surface will have equal and opposite charge. And there will be a voltage across it, which is the voltage difference. Now, when you take the capacitor and you say that it has some energy stored, how much energy is stored? It is given by half CV square or half Q square by C, whichever formula is preferred you can use and whichever is convenient. If charge and voltage is given, okay, you can use this half QV. If charge and capacitance is given, Q square by 2C. If capacitance and voltage is known, then half CV square. All are same thing using Q is equal to CV formula. That's it. Okay, this is the energy stored between the plates of that conductor. How much energy is stored in that capacitor? Yeah. Is the capacitor acts like a battery? Yeah, it's like a temporary battery, but it is not exactly a battery. A lot of people ask me this question, sir, why can't we? This can be a reasoning question. Explain the difference between a battery and a capacitor. First is you can say symbol, sir. I mean, that is like very obvious. Okay, but that is not the main point. Battery symbol is like this. Battery symbol is like this. Capacitor symbol is like this. But don't expect, sir, I will get full marks for that. Capacitor is C, battery is E, capacitor is having the spelling of CAP and all that, and battery has a symbol, spelling of BATT. Don't give such points, okay? So what is the actual difference? Number one, yeah, both of them store energy, but the manner in which they store energy is different. A battery stores the energy in the chemical form, in that electrolytes, but a capacitor stores it in the form of electric field. It's electrical energy which is stored. Got it? That's one of the major difference. Second important point is that when a battery supplies the voltage, it is constant voltage. But when capacitor supplies the voltage, it is not constant, it decays. Right now it is giving 5 volts, immediately after some time it will become 4, then 3, then 2, and it will stop giving that voltage. So it decays almost instantly, whereas a battery supplies the voltage for a quite long time, okay, as long as that chemical energy is stored. Yeah, is that right? Awesome, awesome. I hope this is absolutely clear. The MVSAT results, Pujita, will be announced by November, I think first or second week maximum, because the online examination dates have been extended till 2nd of November. And both online and offline results will be combined together, and the results will be declared and prizes will be distributed. Many people are going to go abroad. They are going to win laptops, phones, headphones, gaming consoles, trips. So many things are there, vouchers, gifts, nice, amazing things. So if you're not yet registered, please register. Encourage your friends also to register free of cost and get study material also, which is also free of cost. Use it. I would say don't just participate. I would say participate with full enthusiasm because there is a chance that you can win. Okay, and at least participate for the the free resources that you are going to get. It doesn't matter which coaching you are in, doesn't matter. Yeah, you should be a part of this. Okay. Having said that, capacitors in series and parallel. So when you connect capacitors one after the other, that is in series, but when it is one beside the other, then you will say they are in parallel. When they are in series, the equivalent capacitance is like the formula for resistors in parallel. So remember this formula 1 by R1, 1 by R2. It's for parallel, but for capacitors, it is for series. It's opposite formulas. But for parallel capacitors, the formula is like series resistance. So you find the total capacitance by simply adding the capacitors C1, C2, C3, etc. What is that one thing which tells you it is in series or parallel? If they are in series, you will see them connected one after the other, and mainly the charge on all of them will be the same and the voltages will be separate, and when added you will get the total voltage. So voltage across 1, voltage across 2 plus voltage across 3 plus voltage across 4 will give me the total voltage, but the charges will be the same in series. In parallel, you will see the charge which comes will get distributed Q1, Q2, Q3, Q4, and the total charge on them will be Q1 plus Q2 plus Q3 all sideways parallel. but the voltage will be same across Q1, Q2, Q3, Q4, C1, C2, C3, C4. All the voltage differences will be the same for parallel. All these things you can mention in your difference table or in your solution when you write the answer. Explain capacitors in series. Derive the formula for capacitance in parallel. What are same, what is different, show the diagram, everything. Formula, all these things you have to mention. Derivations, everything has been done already. Yeah, you can just search for the derivation session on the channel. You will definitely get it. Hopefully it should be there here also, I'm guessing. In the NCRT, where is it? Yeah, this one. Just open this playlist. Okay, you are not added derivation, huh? I should add the derivation right now, I think. Yeah, I mean, now I don't have access, but yeah, I'll add the derivation video in this playlist, guys. That is very important. I don't know how it got missed. I'm so sorry. I'll get it added. Okay, cool. So, shall we do a question based on this then? Let's see what it says, everyone. Observe. The capacitors are 4 microfarad each, and you have to connect it in such a way that you get a total effective capacitance of 6 microfarad. How do you really achieve this? That's the question. How do you really achieve this? Come on, figure this bit out. What are you going to do? How are you going to achieve this particular combination? Come on, my dear students. Yep. All three in parallel, all three in series, two of them connected in series, then the combination in parallel, two of them in parallel, and then the combination in series. You just try it out. You want totally six. So 4 and 4, let's say you connect in parallel, it will become 2, and you connect it to one more in series, it become 6. Yes, I think that should be it. So that means parallel means series, series means parallel for capacitors. So imagine two such capacitors are in series. So their effective combination, because they're in series, it will become 2 microfarad. Okay, that will become 2 microfarad. Now imagine you put one more capacitor of 4 microfarad over here. So that means this one like this. This is 4 microfarad. 4 microfarad. When they are in parallel, you just have to add them. That's it. You just have to add the capacitances. So when you add the capacitances, 4 plus 2 will be 6. That's it. So that is the answer. So two capacitors in series and a third one in, and the combination in parallel to the third. That means C is the right answer. Yeah. C is the right answer. Two series and one parallel, not two parallel and one series. Perfect. Very good. Excellent. Very good. Let's go to the next question, guys, coming up on your screen, and here it is. Wow, wow, very nice question. There is a capacitor of 200 picofarad. It is charged by a 300-volt battery. The battery is now disconnected, and the charge capacitor is now connected to some other capacitor. How much is the final energy and the initial energy in that capacitor? This kind of question is even common in JEE mains, guys. Okay, let's try to do this. I'll take 2 slides maybe. Okay, first of all, let's discuss only the first part. Capacitor is connected to this and battery is disconnected. Only this much part we will discuss. Okay, so this is my capacitor of 200 picofarad and it is connected to a battery of 300 volts. So obviously there will be some charge stored on it, and that charge will be capacitance into voltage. Capacitance is 200 pico. Pico is 10 to the power minus 12 into voltage, which is 300. Okay, so 2 3s are 6. 6 into 10 to the power 4 into 10 to the power minus 12, which can be written down as minus 8, which is 60 into 10 to the power minus 9 coulomb, which is 60 nano coulomb. Is that right? 4 and minus 12 is minus 8. So minus 8, I can write it as minus 9 and put one extra 0. So minus 9 is nothing but nano. So the charge on it is 60 nano coulomb. Now you disconnect the battery. What will happen? The charge has nowhere to run. So you will see plus 60 nanocoulombs and minus 60 nanocoulombs. still sticking onto it. You have just disconnected it from the battery. So the battery is somewhere else. You have not connected that battery. It's gone. The charge is now stuck onto that capacitor. Okay, now let's go to the next part of it. Now that we know how much charge is there. Okay, so we have taken that particular capacitor plus 60 nanocoulombs minus 60 nanocoulombs. Capacitance is how much? 200 picofarad. Now you basically connect it to another capacitor, but the capacitance is 100 picofarad. Immediately what will happen? The charge will begin to flow. Yes, the charge begins to flow. Charge begins to flow, and you will see that slowly there will be some positive charge developed here, negative charge developed here, and this will flow till their voltages become equal. Yeah, this happens till their voltages become equal. So let me show how it will look like this, like this, like this. Voltages become equal. So the voltage will be the same, and voltage is the same, and these two capacitors are there of 200 picofarad and 100 picofarad. This looks to me like a parallel circuit. This looks to me like a parallel circuit. So if that is the scenario, I might as well show it as one single capacitance of 300 picofarad with obviously that same voltage. Equivalent capacitance of the same voltage, and the charge has nowhere to go. So the charge is trapped. So it still has plus 60 nanocoulombs and minus 60 nanocoulombs onto it. So this is the equivalent simplified diagram. Understood what we just did till this point? So whenever you get capacitor disconnected to another capacitor, remember the moment you connect it, the voltages will equalize, charges will get distributed, and because the voltages are same and the capacitors are side by side, you can connect them in parallel or consider them in parallel, and you can just add the capacitances because in parallel you just say C1 plus C2. Okay, now what do you do? Now let's look at the question. The question is calculate the difference between final energy and the initial energy. So we can easily calculate the final energy, guys. Which formula we should use? Capacitance and charge is known. So Q square by C, I believe. So half charge square divided by C. So half charge is nothing but 60 and square nano is 10 to the power minus 9. So squaring it will make it minus 18 by capacitance, which is 300 pico. Pico is 10 to the power minus 12. Is that right? Okay, 60 square, that is 3600 divided by 2 into 300, that is nothing but 600. Minus 18 and minus 12, minus 12, minus 12 will cancel, minus 6 will remain. Okay, so 0 cancels, 36 by 6 is 6 into 10 to the power minus 6 joules, which is 6 microjoules. This is my final energy. This is my final energy. We can also calculate the initial energy which was there. Okay, for initial energy, we can just say half CV square. Capacitance and voltages were given, so we can just use that. Capacitance was 200 pico. Pico is 10 to the power minus 12. Voltage is 300, so put 300 square. So 200 by 2 is nothing but 100, which is 10 to the power 2. And this minus 12 is obviously there. And 300 square will make it 9 and 10 to the power 4. So that makes it minus 2 plus 2 cancels, 9 into 10 to the power 4. Is that right? Oh, capacitance minus 12. Did we do one mistake? 100. Guys, yeah, we did a mistake. This was minus 12, guys. So sorry. And this was 100. I wrote minus 2 by mistake. That was wrong. So this will be minus 10 and plus 4. That is minus 6. Just check it out. So 9 into 10 to the power minus 6 joules, which is 9 microjoules. 9 microjoules. Is that right? So 9 microjoules was initial energy. 6 microjoules is the final energy. So now the final answer, the question is, what is the difference between the final and the initials? That difference will be nothing but final was 6 microjoules minus 9 microjoules. which is minus 3 microjoules. This minus indicates loss of energy. It indicates loss of the energy. Is that right, everyone? Perfect. Great. Very good. Excellent. Let's go to the next concept of combination of resistors. Resistors in series and parallel. This is also a very famous topic which is repeated multiple times. So if you have resistors in series, then the current through them is the same, but the voltages may not be the same. But if you add the voltages V1, V2, V3, V4, that will give me the total voltage. And the resistance just is the total sum of the resistors. R1 plus R2 plus R3 will give me the total resistance. When you have the resistors in parallel, then you will see that the voltage across them is the same, whether this or this or this. The currents will get divided. Whatever current comes over here will get distributed here, here, everywhere. So the current 1 plus current 2 plus current 3 will be the total current. And if you combine them into one single resistance, it will be 1 by R1 plus 1 by R2 plus 1 by R3 is 1 by the total equivalent resistance. So both these formulas, their points, whether currents are same or voltages are same or different or added, and their diagram and their formula. Very, very important. They get it. Yeah, they come again and again and again. Let's go then to a question coming up on your screen. Let's see what does it say. This one. Let's see. Two statements are given. Two statements are given. Select the correct answer to these questions from A, B, C, D. Assertion: the equivalent resistance between A and B is 2R. All the resistors are connected in parallel. Very interesting. Okay. First of all, this kind of diagram, whenever you get, let me tell you, whenever you get this kind of a diagram, forget the other things. It's a standard circuit. This diagram is actually this. This is point A. From there, show two resistors like this. Show one resistor like this. Show one more resistance like this. Show one more resistor like this. This is point B. This is point A. And whatever resistor is there over here has actually come over here. Now, this is a very special arrangement. This is a very special arrangement. This arrangement is nothing but a Wheatstone bridge. Wheatstone, and not just any Wheatstone, but it is balanced Wheatstone. It is balanced Wheatstone. Reason being, this is 2R, this is 2R. Same resistance here also, same ratio. R1 by R2 is R3 by R4. So that is why I'm saying it is balanced. And whenever it is balanced, this part is ignored. So you can just forget about it. And now you have this branch on the top. You have this branch on the top. And you have this branch at the bottom. These two resistors are basically in series. And so are these two resistors in series. So this resistance will be 2R plus 2R, which is nothing but 4R. And this 2R and this 2R will become 4R. Now they both are in parallel. So when you combine them together, you will just get one resistance, which is nothing but 2R, So yes, the equivalent resistance is definitely a 2R in value, definitely 2R. All the resistance are in parallel, that is wrong. So assertion is true, reasoning is false. So option C is the right answer. They are not in parallel, rather they are a Wheatstone's bridge. I'll tell you when it is in parallel. This one is in parallel. This one. Just imagine this, this, and this. And you have a wire here and a wire here. This is as good as saying this resistance, and this resistance are here. So that is in parallel combination. But the moment you have this, and you have not wires but resistors connected across, then this particular arrangement becomes a Wheatstone arrangement. Then this particular arrangement becomes a Wheatstone arrangement. Keep that in mind. This is Wheatstone arrangement. You don't have to show this resistor in between, or even if you show, it will be ignored because it will be balanced. So you can completely ignore this, ignore if balanced, ignore if it is a balanced bridge. And for balancing, what is the criteria? If this is R1, this is R2. If this is R3, this is R4. So for balancing, R1 by R2, this by this, and this by this, which is R3 by R4, they should be basically equal in amounts. Is that okay? Absolutely clear? So that is why the option is C. Assertion was correct, but they are not in parallel. Rather, they were in Wheatstone's bridge arrangement. Interesting question, isn't it? Yeah. Perfecto. Shall we go ahead to the next one? Coming up on your screen. And here it is. What does it say? There is a network of resistors as connected, and there is internal resistance. Compute the equivalent resistance of the entire circuit. Great. Now, as you can see over here, these two resistors are in parallel. So are these two resistors in parallel. So if you ask me what will be the equivalent resistance, R1 R2 by R1 plus R2, you can use that formula, or 1 by R1 plus 1 by R2 also is the same thing. Preferably for two resistors, use R1 R2 by R1 plus R2. So 12 into 6 divided by 12 plus 6, right? So 12 into 6 divided by 12 plus 6, which is basically 18. 6 goes with 18 three times. So this will become 4 ohms. This 4 and 4 are equal. So 4 into 4 by 4 plus 4 will just make it 2 ohms. So now if you draw an equivalent circuit, it will be nothing but 2 ohms over here. You will have 4 ohms over here. Rest of the things in between, this is 1 ohm, and here also you have 1 ohm of internal resistance. All of them are basically in series only. So that's why the equivalent resistance will be 2 plus 1 plus 4 plus 1, 3 plus 4, 7, 7 plus 1, 8. 8 ohms is the equivalent resistance. Okay, I've done it in shortcut. Don't draw such random shabby diagrams. Draw it systematically. Mention that this and this is in parallel. So equivalent is this much. This and this is in parallel. The equivalent is this much. I think steps will be mentioned here. So if you mentioned it stepwise, you will get full marks. Otherwise, they will cut marks. Show the reduced circuit also. And then finally show. Hence, the equivalent. All of them are in series. Hence, it will be just R1 plus R2 plus R3 plus R4, which is 8 ohms. If you show like that, you will get full marks, or else they will cut the marks. Okay. Let's go to the next concept of Kirchhoff's law. Let's go to the next concept of basically Kirchhoff's law, guys. Yep. Let's see. Kirchhoff's law are two. One is KCL, one is KVL. Current law is applied for a junction, for a node, which means where the wires meet, 2 or 3 or 4 or 5 wires are meeting at a place, that is basically a junction where you apply it. Some currents will be coming in, some currents will be going out. If you add all the currents which are coming in, that will be exactly equal to the sum of all the currents which are going out. All the currents going in is equal to all the currents going out. So first of all, mention that Kirchhoff's current law is applicable for a junction or a node. Show the diagram, you'll get marks for that. Then mention that sum of the currents entering in is sum of the currents exiting out. Then mention it is based on the conservation of charge. When you mention all these points, you get full marks. Got it? Conservation of charge, because whatever comes in goes out, and applicable for a junction, and the formula. That is Kirchhoff's current law or junction law. Second one is called KVL or a loop law or Kirchhoff's voltage law. It is applicable for a loop. So if you have a complex circuit and you are going around that circuit, okay, you are going around that circuit and you come back to the same point. As you go across the circuit, you encounter different devices and they will all have some voltages across them. V1, V2, V3, V4, V5, something. But if you add all the voltages on your way, and when you reach back, you will find the sum of the voltages across all those devices will be zero. It is based on the conservation of energy. Kind of makes sense because if you are coming back to the same place, there should be no voltage difference. If I'm encountering 2 volts and 3 volts on my way, then I should also encounter 2 plus 3, which is 5. So negative 5 volts, some other device. So 2 plus 3 minus 5 will become 0. That is Kirchhoff's voltage law. When you use both these laws together, so this can be a big question, then irrespective of whether they are in series, parallel, how many batteries are there, how many resistors, capacitors are there, you can always figure out the currents, charges, etc. in that particular circuit. So it is used for solving complex circuits where you cannot simplify them by normal means, and you can use for finding the currents, voltages, resistances, capacitances, etc. So you mention these applications, you will get the answer. Let's see it via an example, by the way. Let's take this particular example, guys, coming up on your screen. In the given circuit, assuming point A to be at 0 voltage, use Kirchhoff's rule to determine the voltage at point B. Very interesting question. Let's see what do we do in this case. First of all, let me choose to understand that to find voltage at point B, I think I will need the currents in the circuit, without which I will not be able to solve the problem. Is that right? Everyone with me? Okay. So first of all, let me assume some currents. Let's assume such some current I1 is flowing. So same current I1 will be flowing here. Oh, why have they mentioned 1 ampere? Oh, already the currents are mentioned now. Ayo. Then I don't even have to find that. If I don't have to find that, then I just can say this is like this. This is I1. That same current will be flowing here. I1 is 1 ampere. Okay, perfect. Here 2 ampere is given already. So let's say I call this as I2. That same current of 2 amperes, which is I2, is flowing here. Now look at this junction, guys. At the junction D, what is coming in versus what is going out? Okay, so let's think about this current as I3. So what is coming inside is just 2 amperes. What is going out is 1 ampere and that I3 current. So from this, it is very obvious 2 minus 1 is 1. So the current in 2 ohm resistor is basically 1 amp. That part is done. So once I get that, here is what I'm going to do. I now know this current. Is basically 1 ampere. This 1 ampere is here. This 2 amperes is here. I know that this point is at 0 volt. I want to find the voltage at this point. So I'll try to figure out how I can reach B via some simpler way. Maybe I can go like this. So I'm going to travel from this point A to this particular point B like this. Okay, I'm going to travel. As I go from point A to point B, I will encounter voltages, and because I'm not coming back to the same place, there will be some voltage difference. So the voltage at point B will be voltage at point A plus the sum of all the voltages that I encounter across all the devices on the way. All the devices on the way. Okay, so let's see. What is the voltage at point A? It is nothing but 0 plus. First device that I encounter is a battery. and I'm going from negative to positive. So when I go from negative terminal to the positive terminal, it is a jump. I'm going to a higher voltage by battery's volt. So it is plus 1 volt. It is positive 1 volt. Here there is nothing, but here I encounter a resistor, and for a resistor, this point is at a higher voltage as compared to this point, which is at a lower voltage, because the current always goes from high to low in a resistor. So because I am going from high to low, the voltages should decrease. So plus some negative number will be there, and voltage across a resistor is I into R. So it is always nothing but I into R. So current, whatever it is, 2 into basically R1. That's it. These are the only devices. I finally reach B. So hence it will be nothing but 1 minus 2 times of R1. 1 minus 2 times of R1. Is that clear? Everybody? Pakka? Very good. Very good. That's how you can write it down. Now, but R and R1 are not given. Devils, I will let you know when the Sigma crash course is going to be started. Yeah, don't worry about it. It will come very, very soon. Okay, perfect. Now, the problem is R1 is not given to us. Problem is R1 is not given to us. So, I can't leave the answer like this. So, I have to choose a path which is convenient. This was just an example to show how to apply Kirchhoff's law. This path was not favorable because R1 was not known. So what I can do is, this is 0 volt. How about traveling like this? Then that will be better. So the voltage at point B will be voltage at point A plus sum of all the voltages that I encounter on the way. At A, the voltage is 0. The first device is a battery going from negative to positive. So it's a jump. So plus 1 volt. So plus 1 volt plus here this resistor has a current which is going like this of 1 ampere, and current always goes from high to low. But how am I traveling? That is important. I'm going like this, then I'm going like this, then I'm going like this to finally reach B. I am going from low voltage to high voltage. So it will be a jump of positive current into resistance, current into resistance. Lastly, there is a battery of 2 volts, positive to negative. It's reducing the voltage. So minus 2, that's it. And finally, I reach point B. So as you can see, this is 1 plus 2 minus 2. Hence, it will be 1 volt. So voltage at point B is basically 1 volt. So we choose a path which is convenient. This path was there, but it was not convenient because I don't know R1. And we use also Kirchhoff's current law. Okay, perfect. So I think we can keep one question as homework. This is straightforward question. Two batteries, sorry, one battery here, one battery here, and there is a resistor here. Currents have to be found in the branches. So just try to find the currents. Two loops are there. So you can choose maybe one loop like this and one loop like this. Apply Kirchhoff's law, you will get the answer. So try this out as homework question. Solution is there on the next slide. Yeah, will you be able to do it, guys? Yes, no, pakka, done. Great. Let's go to the next concept of motion of a charge in magnetic field. We have come to that unit, magnetism. Let's do those concepts. Motion of a charge in a magnetic field. And if you guys have forgotten to like the session, please like the session right away, right now. Come on, guys. What are you guys doing? Waiting for? Yeah, do it right away, right now. Great. So motion of a charged particle in a magnetic field. First of all, Lorentz force. If you take a charge, throw it in a magnetic field, the force which acts on it is neither in the direction of the motion nor in the direction of the magnetic field. It's in a weird direction given by the right hand rule. You place the four fingers of your right hand in the direction of velocity, then slowly bend it towards magnetic field. See where the thumb pops up. The thumb pops in the direction of the force acting on the charge. So there is a cross product involved there. So you will see it is charge value into velocity cross magnetic field. If the charge is negative, then this whole expression becomes negative. So wherever the thumb is pointing, exactly opposite to that, the force will be acting. But for a positive charge, you don't have to do anything. Use the right hand rule. Simple. Okay, so like I said, the force is neither parallel to velocity or magnetic field, rather it is perpendicular to both. Keep that in mind. So if my charged particle had velocity in this direction, you will see maybe the magnetic field is in some weird direction, maybe like this. And this is some kind of a plane, maybe. This was some kind of a plane, maybe. Then our force will be in a direction which is perpendicular to that plane, like this. It's perpendicular to the magnetic field, and it is also perpendicular to the velocity, like that. So that's how the force is. This force doesn't do work. The force doesn't do any kind of work. So it can only change direction. It can only change direction, and it can't change speed. This is very important thing. It can come as a give reason also, or explanation, assertion, reason, whatever, because the force is perpendicular. So it can only turn the particle, but it can't improve or decrease the speed. Okay. Now there are two kinds of motions which are generally analyzed. One is perpendicular, or one is along the magnetic field. So when you put it perpendicular, it does uniform circular motion. So the particle goes round and round. Magnetic field is here, velocity is here. You will see the particle will go round and round. It will only change direction. And the radius is given by mv by qb. Time period is given by 2 pi m by qb. Very important. Helical motion is also possible if you throw the particle at an angle to the magnetic field. Then instead of going round and round, that circular motion moves forward. So it looks like a helix. It looks like a helic, like a spring-like motion. More than that helical motion, you should concentrate on that circular motion, which is very, very common. So mainly the derivation and the formulas and the numericals based on it. So if you have a charged particle of mass m, which is given a magnetic field perpendicular to it, show that it describes circular motion, write the radius formula also. So the derivation is very, very important. So you first show a charged particle q like this. You show the magnetic field which is there in the inside or outside, say inside in this case. If you throw the particle like this, velocity is there, magnetic field is inside, the thumb goes up, so the force is directed in this direction. Now, because the force is perpendicular, it can't give any tangential acceleration. So it can only provide centripetal acceleration. So because of that, the velocity changes the direction, but always the force remains perpendicular to the velocity. So hence that force behaves like the centripetal force, which is directed towards the center for that circular path taken by the charge. And centripetal force is mv square by r, standard formula. So what is the force value? Use this qv cross b, qvb, but coincidentally velocity is perpendicular to magnetic field, so sine 90 will be 1. So force magnitude, which will be q into vb sine of 90, so that will be just qvb. That's what you will use over here, is equal to mv square by r. Velocity will cancel, so radius will become mass times the speed divided by the charge into the magnetic field inside. That's it. So this is the derivation part and the formula part of the circular motion when the magnetic field is perpendicular. Okay, fair enough. Pakka. Let's go to some questions then. Let's go to some questions. Here it comes on your screen. A proton might be moving with some velocity in a non-uniform field, and the path taken is like this, some weird path it is taking. So the proton is going like this, then like this. The path followed is always is in the plane of the figure, and the direction of the field near P, Q, and R. What can you say about the strength of the magnetic field also? Wow, very nice question. Think about it. First, let's go to point P. At this particular point P, if you ask me, at this point P, the velocity is like this, but it is turning in this direction. So I think because of that, the force will be somewhere over here. And if the force is somewhere here, Where should the magnetic field be at point P? I think it should be inside. Magnetic field vector should be inside because velocity cross B will give me the force. So at point P, the magnetic field is inside. That is very, very obvious. Is that clear? Yeah, Pakka? Yeah. Very good. Very good. Excellent. Next, what about point R? What about point R and what about point Q? Here also point Q, it is going almost like this only at point Q. Observe this. At point Q, the velocity is like this. So if it is turning like that, then the force is still over here only. Force is still here. So 100% the magnetic field will be again inside only at point Q. At point Q. But what about at point R? At point R, it is going like this. The velocity is here at point R. So the force must be here. The force is here. Velocity cross B is upwards. So it should be towards me. V cross B is downwards. So the magnetic field will be towards me. The magnetic field vector will be towards me. So here it is towards me. Here and here it is away from me. So the first part of the question is done. Where is the magnetic field oriented? What can you say about the field strength? That is interesting. If you compare the radius, you will get it. Mass, speed, Q and B. Mass is not changing, speed is not changing, charge is not changing. So radius is inversely proportional to B, or magnetic field is inversely proportional to the radius. If you notice over here, the radius is this much. Here the radius is very, very large because it is going on a big path. And over here the radius is very, very small because it is going in a small path. Here the radius is decent enough, maybe. Here the radius is very, very large because the path is very hardly curved. Here it is curved a lot, so it is having very small radius. So from this, wherever radius is small, the field is going to be strong. So field is the strongest at R because this is inversely proportional. Then it is more at P and the least at Q because the radius is the largest here. So field is the smallest over here. Is that making sense? How we are comparing it? Yeah, everybody with me? Absolutely, absolutely clear. Very good. Proud of all of you guys. Amazing go. Let's move to the next question on your screen, and here it is. Let's see. What do you answer? Come on. A particle of certain mass and charge describes a circular path of some radius. If the mass and the charge were now changed, what is the new radius of the path? So let's start. Please remember, sometimes you might not be given options. You might have to solve it properly, show the steps. So this is how it would look like. So the initial radius would be mv divided by q into b. Now for the new part. So the new radius will be mass is 2m, velocity is the same, and charge is nothing but q divided by 2, same magnetic field. So this number 2 goes on the top, so it will become 4mv divided by qb. Notice mv by qb is already r, so it will become 4 times of r. So the new radius is 4r, hence it is option D. Hence it is option number D. Very straightforward, everyone. Hi Divyanshi, welcome aboard everyone. How many of you are discovering the channel for the first time or probably your first week on the channel? Let me know quickly on the chat box. Have you seen that we have CBSE content on the channel, and that too in pure English? We have CBSE playlists which will be updated regularly, plus you can search for derivations plus other sessions, and obviously detailed classes for 12th and 11th JEE. The older playlists and the newer playlists both are there, plus one shots, formulas, paper discussions, right, marathons, last minute revisions, everything on the channel, guys. Yeah, and please subscribe. That is very, 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 very important, or else you will miss out on all the amazing content. Correct? Okay, perfecto. Let's go, guys. And after this topic, I think we should be in a position to take a break, I believe. Yes, I think last two topics and then we'll take a break and then we'll continue. Okay. So Biot-Savart's law and Ampere's law. Let's do both of them. Biot-Savart's law tells me how much is the magnetic field at any location. How much is the magnetic field at any location due to a wire carrying current. The formula is given by mu naught by 4 pi. I is the current. DL is the small wire due to which the field is created. Cross product with R unit vector. R is the unit vector where you are trying to find the field. So imagine this is that small wire which is carrying some current, having length L, carrying that current I. It's a part of a big wire, and this is where you are trying to find the magnetic field. So this is R vector, and if you take a unit vector of R, this is how it will be, unit distance. At this particular point, there will be some magnetic field dl cross r. So I think it will be inside. If you do the right hand thumb rule, this will be the small magnetic field due to this current carrying element. So I dl cross r hat divided by r square. Divided by r square. It's used to find magnetic field due to a current carrying wire. You can use it to find magnetic field due to a loop, due to a long wire, or due to solenoid, or on the axis of a coil. All these things you can use it to find the magnetic field. All right. But just like you had Gauss's law in electrostatics, you have Ampere's law in magnetism. This is a much simplified version which helps me calculate magnetic field for symmetric bodies without complicated procedures. So first keyword, it simplifies it. Number two, it is used for mainly symmetrical bodies. Here, for using Ampere's law, we don't need a surface, rather we need a closed path, which is also called Amperian path. Okay, for symmetry cases and for a closed path. So imagine there were wires like this. There is a wire here, there is another wire here, another wire here, another wire here, another wire here. All these are carrying currents I1, I2, I3, I4, I5 like that. You take a path, not a surface. Let's say you are going like this. You are going like this. This is an Amperian path. And at every single point, there will be a magnetic field due to all the wires. Let's say it is B. And you are moving slowly across this path. And every time you move, you travel a distance of dl. So if you do B vector dot dl vector, B dl, B dl, B dl, B dl, B dl, if you add them, that means you are integrating. And you're coming back to the same point from wherever you started. Let's say you started from here, BDL, 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 you do, and you start and come back at the same point. So you integrate them, you get the answer as permeability into I enclosed. Remember, mu naught is permeability, and the value of permeability is nothing but permeability of free space is 4 pi into 10 to the power minus 7 SI units. 4 pi into 10 to the power minus 7 into I enclosed. Now in this case, whatever is the I enclosed is all the currents which are within this perimeter. Like I1 is there, you also have I2 and you also have I3. I4 and I5 will not be enclosed currents. But not all the currents are positive, just don't add them, be careful. Like if I'm moving like this, so take my right hand, four fingers will curl like this. Thumb will point in the positive direction. So I1 and I2 are positive. So this is positive, but I3 will be negative. So however you are moving in that path, curl your fingers, the thumb points in the positive direction of the current. So that is Ampere's law. It is used to find, field due to a long wire, solenoid, toroid, all these things. That is the application of it. Yeah. Perfecto. Everyone. Hello, Bhavesh. Hi, Yogamini. Yes. Vaishnavi will conduct it soon. Yeah. Don't worry. Yeah. Yeah. Prism and dispersion, that will happen. Just let me just complete these marathons. All right. Great. Very good. Based on that, you have the derivation for, you know, long wire, straight wire, all these things. Please go through these derivations. Sometimes they can come, may not come also. And if you want to look at those derivations, just search for derivation over here. Derivation. Just search for derivation and you will get it. CBSE board, most important derivations. Okay, just go through this very important video. Cool. Okay. Now, this particular question, like this one, state Ampere's law, show that with an example and find the magnetic field due to a long wire. Like this has been commonly asked. So what is Ampere's law? Ampere's law states that the total integration of magnetic field dot producted with the length vector along a closed path is equal to permeability into the enclosed current. And write the formula, whichever I give it, with a diagram. Which was the diagram? I just showed it to you. This one. Mention this, and show the diagram with the formula. You will get full marks. That is number one. Second part is where you have to show the application. So let's say you take the example of a long wire carrying current. You take a loop, which is an imaginary loop. Say you start from here and come back at the same point. DL, 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 and you come back over here. Every place there will be magnetic field, and the magnetic field at every single place will be along the tangent only. So when you do the dot product of B vector dot DL vector, it will be B DL cos 0 because they both are parallel, which will just make it B DL. Got it? So B dot DL will just become B into DL at every single place. That's the beauty of this problem, because magnetic field is just going to be parallel to my small dl vector. So when you apply Ampere's law, on the left hand side you have integration of B dot dl, which will just be BDL, right? It will just be BDL. B is a constant, so it comes outside at every single place. So what is integration of dl? That means if I add all the small arcs, I'll get the perimeter of a circle, which is 2 pi r. So B into 2 pi r is the LHS. RHS is mu naught into the inside current. There is only one wire, so the current is just I. So you want to find B, so take that 2 pi r below. So it will become mu naught I divided by this 2 pi r. So this is how easily you can find the magnetic field due to a long wire carrying current, and the fields are in concentric circles. If you want, you can also show the diagram of it, where you show the wire which is carrying that current, and you show that yes, the magnetic field around it is in the form of concentric circles, but at the same distance the field magnitude is the same. So this is how it looks like. Great. So having said that, let's go to the last part, which is the force and torque on a magnetic loop carrying current. So whenever you have a current carrying loop, it will experience some force and torque. Let's see that. For that, first of all, if you just take a simple part of a wire which has some current, let's say that length is L, then if it has some magnetic field passing through it, then there is a force acting on it. That force is given by the cross product of I into length vector into B vector. I L cross B gives me the magnitude of the force on a single wire which is carrying some current. Now, if you use this concept for a loop, loop has current which starts from the same point and comes back to the same point, then the net effective force on it is 0. Very, very important. Okay, because the total length will be effectively 0, or you come back to the same place. The net force on a loop carrying current inside a magnetic field, let's say the magnetic field is like this, is always going to be 0. It could be anywhere, guys. The magnetic field can be like this, anywhere. Doesn't really matter. Okay, doesn't matter what the direction is, how the loop is, force is always 0. But there is a torque acting on it, and to find the torque, we define a quantity called as the magnetic moment. So wire carrying current in the form of a loop develops polarities, very, very important. So if you curl your fingers in the direction of current, the thumb points in the direction of the north pole of the loop. This is south pole. This is nothing but an electromagnet. This is an electromagnet. And you have two polarities. So it will now develop a dipole moment. It will have now a magnetic moment. Magnetic moment. And this magnetic moment is nothing but equal to number of turns in that coil into the current into the area. Okay, is that absolutely clear? Just 1 second, please. Yeah, it will be number of turns into current into basically the area of it. Hello, AG criminal, welcome aboard. Yeah, yeah. Hi, Ekanshish. Hi, Yogan Mani. Welcome aboard, everyone. Okay, perfecto, perfecto. So the torque acting on that loop is not zero, force is. And just like we had seen dipole's torque, same way the torque over here is dipole moment but into magnetic field. Torque is dipole moment into magnetic field. Instead of P cross E, here it is magnetic dipole moment into magnetic field. That's it. Same formulas are applicable. So let's have a look at some of the questions. If you have a loop carrying current in the clockwise direction, which is in the XY plane, and the magnetic field is along Z axis, the tendency of the loop will be to do exactly what? Draw the diagram. Yeah, draw the diagram. Things will be very, very obvious. See, we have a loop which has current in the clockwise direction. That means like this. This is how the current is. It's in the XY plane. And the magnetic field is along the Z axis. That means towards me. That is towards me. So how will the force be? Force is IL cross B. B is towards you. Let's say I take this element, or let's say this element. Length is there, magnetic field is towards you. Length cross B. Length is there, B is towards you. So it goes down. So here the force is like this. So naturally here it will be like this. Naturally here it will be like this and like this. Same thing. So what is this trying to do exactly? Obviously it is trying to shrink. It will neither move along X or Y or Z. It will try to condense that loop. So answer is shrink. Yeah. Perfect. Makes sense, right? Awesome. Let's go to the next question. I think it is an assertion reason question. Two statements are given. Okay. Assertion says the deflecting torque acting on a current carrying loop is zero when its plane is perpendicular to the direction of the magnetic field. Okay. Let's understand. This is my loop. This is my loop. Is zero when the plane is perpendicular to the direction of the magnetic field. Magnetic field, if it is like this, we know the magnetic moment is like that. This is the magnetic moment. So theta is 0. So sine 0 is 0. So torque is 0. So hence this is correct. You can see the loop's area is perpendicular to the magnetic field. Perfect. The deflecting torque acting on a loop of a magnetic moment in a magnetic field is given by the dot product. Oh, this is definitely wrong. Dot, no, cross product. So assertion is true, reason is false. So I think C option is the most appropriate answer. Yeah, perfect. Got it, guys? So that is the right answer. So now we are going to have a short break of around 20 25 minutes, and then we'll return and complete the rest of the topics. Okay, cool. I'll see you guys in some time. We'll return after a short break, right? Okay. Now it's around 8 o'clock, so around 8:25 or something, we'll return. Let me know if I'm audible and visible to all of you. Yes, the break time is over, and I hope you had a great dinner, and it's time to move on to the second half of the session. And I was getting some messages also. I was just reading. Students were like, "Sir, revise the theory quickly. We'll go on to more questions." So I'm like, "Okay, fine, no issues." So we'll revise the theory a little quicker and we'll concentrate more on the questions while then. All right. Hi, Praveen. Welcome, Sudarshan. Welcome, Undefined Easy Math. Siva, welcome. Ikanshit, Devanshi, Supercar, welcome. Yes. Today we'll be doing all the chapters, topics, not chapters per se, topics we are doing, but I think almost all the chapters are involved. Yeah. So Faraday's law is a law which tells me how electricity gets generated when you change a flux through a coil. And when I talk about flux, I'm talking about magnetic flux. So if you have a magnet close to a coil and you rotate the coil, rotate the magnet, move the magnet, change the size of the coil, etc., the flux passing, magnetic flux passing through the coil changes. How quickly you change it, that is d phi by dt, rate of change of flux, decides the batteries or the imaginary battery's EMF, meaning the coil behaves like a battery whose EMF is given by d phi by dt. The magnetic flux, same formula like electric flux, it is magnetic field into area into cos theta instead of electric field into A into cos theta. This formula gives me the magnitude, that means how much volts will be produced. The direction is always given by Lenz's law, which is based on the principle of energy conservation. It just tells whatever current is being or voltage is being produced will always be such that the field created by that voltage, induced voltage or current, will always try to oppose whatever is happening. So if a magnet is trying to come close, the current will try to repel the magnet. If the magnet is trying to go away, it will try to pull back the magnet. Okay, so it will always try to oppose any kind of change on the basis of conservation of energy. Okay, so that negative sign in the Faraday's law is based by the Lenz's law. Cool. So let's begin. Let's go to some questions now. And here it comes the first question, guys. Here it comes the first question. Hi DBDB. Hi Ahmad. Welcome. Welcome everyone. Yes, let's start Minecraft. Yeah, there are some PYQs. Some of them are PYQs. I have not mentioned the PYQ year. Like some places it is mentioned, but some places it is not mentioned. So there are PYQs, NCERT back exercises in text, exemplar questions, previous year questions, and most important models. All these are mixed questions only. If you have a wire of some irregular shape and you turn it into a circle and the magnetic field is inside, predict the direction of the current. See, I'll tell you what. Right now, if you look at the coil over here, there is some flux passing through it. There is some flux passing through it, and that flux is passing through this much area. Now imagine that coil becomes a circle. That coil becomes a circle. So now the flux will pass through entire thing. So in this transition, what will happen? The area will increase. So flux will increase. So when the flux will increase, what will the induced magnetic field try to do? The induced field will always oppose the flux because the flux is trying to increase. It will oppose that flux. As you can see, the magnetic field is going inside. It is mentioned by a cross. So to oppose it, you will have to create an induced field in this direction. So to predict the direction of the current now, take your right hand thumb, put it in the direction of the magnetic field. The fingers will curl in anti-clockwise direction. So this is how the current will be induced. So always remember Lenz's law always opposes the change. As you can see, the field lines are going inside. The moment you change the shape, more lines will go inside. So area will increase, flux will increase, which is not liked by Lenz. Lenz will say, I will oppose that increase. So it will create an opposing flux and you will see induced field will be towards you. So use your right hand thumb rule and you will get the current's direction. Very straightforward. Let's go to another question. which is based on, I think, motional EMF. There is a rod and it is rotating through an axis through the center and perpendicular to its length. The uniform field is plane, perpendicular is switched on. Calculate the EMF induced between the center and the end of the rod. Now, this kind of question has direct formula. Let me tell you, whenever you have a rod which is, let's say, rotating about an axis and there is some kind of magnetic field over here, okay, B, this is length L, this is omega, then there is EMF developed across the ends of that rod. That EMF is half B omega L square. Half B omega L square. Now in this scenario, what is happening is, if you observe, the rod's length is 2 meters, but it is not rotating at the end, it is rotating about the center with an angular speed of 60 revolutions per second. 60, sorry, revolutions per second, and each revolution being 2 pi radians. So into 2 pi radians per second. So that becomes 120 pi radian per second of angular speed. And the length of the rod that you will be considering is exactly this much, 1 meter, because the question says how much EMF is generated between the center and the end. So this will be half, magnetic field is 2, omega is 120 pi into length, which is 1 square. 2 cancel, so 120 pi volts will be the right answer. Getting it? Calculate the EMF between the center and the end of the rod is asked. This formula is very, very important, which is based on the concept of electromagnetic induction. Half B omega L square. Cool? I need to join the J batch. How do I know the details? Siva, I'll be giving up all the details very, very soon. As you have seen, maybe I have posted some videos also on it on the channel. As you might have seen, the trailer has already come. The Sigma Warriors Assemble. Yeah, because the JEE 2026 crash is going to be coming very, very soon. And let me tell you, this is the first time in the entire country this kind of crash batch will be launched, because we have revamped literally everything. In fact, for all the kids who are barely done anything or just dependent on NCRT, or who have tried joining a coaching but not much has been done, this will be like a blessing, not even in disguise. I will tell you all the details. And if you are scoring average, decent marks, you have been giving mock tests, but somehow you're missing out on getting those marks, forget learning everything because hardly any time is left. This is going to be an immense rank booster. So hold on to that. Just in next 1 week, you are going to get all the details. Okay, it's going to be the Sigma crash, and this is completely different than any crash batch, whether it is online, whether it is offline. You will see why. Let's go now to the next question on your screen. Here it is. This says, in the given diagram, a bar magnet is taken, moved towards the coil. Predict the polarities of A and B in that capacitor based on, again, Lenz's law. Lenz says that whatever you try to do will be opposed. So if the magnet is trying to come close, you have to oppose it. You have to oppose it. Yes, you have to oppose it. And to oppose meaning you have to repel it. In order to repel it, what you will do, if the north polarity is towards you, yeah, so the north polarity of this guy will be here, south polarity will be here. So this is how it will be. So this north and south will happen if your thumb is pointing towards the north and the fingers of your right hand, the 4 fingers of your right hand are curling like this. This is how the right hand thumb rule is all about. Yeah. So the thumb will point towards the north pole to south pole. This gives me the direction of the induced current then. Yeah. Only then the north pole will repel it. It will oppose that change, that is by Lenz's law. So the current should be like this. The current is like this. That means, imagine the positive charge will be on A and current is going out like this. That means the negative charge will be on uh, A, like this. Yeah, is that right? Current is, no, sorry, what did I just say? My bad. The current is going like this. It means A will behave like the positive terminal and B will behave like the negative terminal. Is that right? Everyone? Yes, no? Come on, tell me quickly in the chat box. Yeah, B will be positive, B will be negative, and A will be positive. That's what generally people will try to think. And that is why, it is a HOTS question, higher order thinking question. See, a lot of people think, sir, since the current is going like this is like a battery, and this is positive, this is negative. Correct. If the terminals of the battery were asked, then that would be positive, this would be negative. If it's a battery's terminal. But this is not a battery. The question is, it's a capacitor. So think, if it's a capacitor, when will the current be like this for a capacitor? If this is a battery, this is correct. But for a capacitor, try and understand, if the current is being supplied, the positive charges are being taken away. So this plate will become negative, and those positive charges will come and fall on this plate. So this plate will become positive. So actually speaking, B will be positive in nature and A will be negative in nature. Understood? So the catch is that it is a capacitor, it is not a battery. If this was a battery, the terminals will be this positive, this negative. But if it's a capacitor, this will be this negative, this positive. So that is why it's a HOTS question. Yeah, loved it. Yeah, perfecto. Yeah, yes, awesome, awesome. Ayo, Naresh, I don't think such changes are allowed, man. Yeah, because I think you should have thought carefully before anything. So, guys, that's why I have posted the video well in advance on the channel. I know maybe some things would have been launched before that also. So that you do not join any crash course right now, because the best English crash course is going to be launched in a couple of days, not even weeks, just couple of days. Yeah, hi Arushi, welcome aboard. But that internal change, I doubt that will happen. Okay. Let's do the next question. A square-shaped coil of certain centimeters having some turns is placed perpendicular to the magnetic field, which is increasing at 1 Tesla per second. The field will create an EMF. How much is that EMF? This is again Faraday's law, which says it is EMF is d phi by dt. And the flux, obviously, is magnetic field into area. Magnetic field is changing, area is not changing. And obviously number of turns are also there. So I'll have to multiply this with n so that I calculate the actual flux, which is each coil's area n number of times, number of turns times. So area and turns will come outside and dB by dt will stay inside. So area of the coil will be nothing but 10 centimeters means 0.1 meter into 0.1 meter. Number of turns I believe is 100. And dB by dt is given to be 1 Tesla per second. This will just become 1 volt, and hence I believe that is the right answer. A square shaped coil of side 10 centimeters, 0.1 into 0.1, number of turns is 100, so this will be 1. So I think the decimal place was not there, or maybe it was not 100 turns, maybe it was 10 turns, one of it. I'm not really sure where that mistake has been happening in the printing. Yeah, so it is just going to be 1 volt. It is not 0.1 volt. So I'll just remove this. This is not point. This is just 1 volt. Oh, 1 volt is there as the option. I'm so sorry, guys. I didn't see that option. Sorry. 1 volt is there over here. Yeah, it's right over here. Okay, so 1 volt is the right answer. Let's go to the next one, which is self-inductance, mutual inductance, and transformer-based questions are also very, very common. So let's have a look at it. Self-inductance is a property where a current change in a coil is opposed by the coil itself. And the EMF will try to always oppose that change. Meaning, if in a coil the current tries to increase, the EMF will try to oppose that current. If a current tries to fall down, that EMF will support that current to improve the current. So that EMF is L di by dt. L is the inductance, unit is Henry. Mutual is when there are two neighboring coils and a current in one of the coils begins to fall, So this coil will oppose that change. So if the current is falling, this neighboring coil will induce an EMF in this coil and prevent that change to happen, or oppose that change rather. And if this current will try to increase, this coil will oppose that increase and try to reduce that current. This is called mutual inductance. So EMF in this coil is M di by dt. So EMF in one of the coils, an EMF created in this coil, is how fast the current is changing in this coil, primary coil, and the relation between them is M times di by dt. M is the mutual induction coefficient. Okay. Transformer is based on the concept of mutual induction. A transformer is a device which changes the voltage which is coming inside and going outside. Either the voltage can reduce, it is called step down. It can increase, it is called step up. And it depends on the number of turns and all of those things. And whatever input voltage you give and the output voltage you get, the primary and the secondary, if you take the ratio, it is exactly the ratio of the turns on the primary side and on the secondary side. That is the working principle of a transformer. So any current which is going here, if it is AC alternating in nature, then those current will create a flux. That flux will pass through another coil and it will create electricity in the other coil. So mutually inducted, you will see the secondary coil will create a EMF, and that's the working principle of a transformer. So these are the main key ideas. Let's start looking into the questions coming up on the screen, and here it is. All right. Calculate the current, if what is it? Current in a circuit fails steadily. Bum AU A to ayo, what is this? Which language is this? In an average of 200 volts induced, then the calculate the. Okay, I think there is some typing mistake, so ignore this statement. So if the current is changing in so much time and EMF is this much, how much is the self-inductance? So self-induced EMF has a formula of L times the change in the current upon the time taken, That's it. In this particular situation, you know the EMF, you know how much current has changed. It fell from this much to this much. You also know the time. Easily you can find L. So this is the concept and the formula used. This kind of questions are very common. Say for example, it was told that this is 200 volts. Let's say the current goes from some amperes, maybe 10 amperes to 0 amperes in a time of how much seconds? 10 milliseconds. Milli is 10 to the power minus 3. So how much will be the value of L? It will become 200 multiplied by 10 multiplied by 10 to the power minus 3, whole thing thus divided by 10. 10 cancels. So it will become 200 into 10 to the power minus 3, which is 0.2 Henry. So that's how you can find the answer. Okay, just L di by dt. Let's take up more examples, guys, on your screen, and here it is. Two concentric coils are there, one small and one big. So find the mutual inductance between them. This is also a very common question. Even in JEE, you would have seen this kind of thing. So let's start by drawing the diagram. Let's say this is our big coil, and inside of that, we have a small coil over here, like this somewhere. Now, what will happen is this big coil, which is carrying some kind of current, let's say this is primary, this will create a magnetic field here. This will create a magnetic field here. I will call that as B1. Now we can find that B1 very easily. It is magnetic field at the center of a coil. So it will be mu naught. I think it is just two circular coils. Mu naught I1 divided by 2 times of big radius. So whatever is that radius will be over here. Now that field will obviously create some kind of flux over here. Will create some kind of flux in that secondary coil. So we can find that flux in that secondary coil, which will be nothing but area multiplied by the field multiplied by cos of 0, because angle is 0 degrees. Area is pi small r square. Field is nothing but mu naught I1 divided by 2r, cos 0 is 1. So this will become pi mu naught r square divided by 2r into I1, that is phi 2. As you can see over here, whenever flux in the secondary is proportional to the current in the primary, that constant of proportionality is M. So that is basically your mutual inductance. Mu naught pi r square divided by 2r. Very simple the derivations are. I mean, you can don't even have to memorize it, go step by step. Find the field, from that find the flux, somehow show flux is proportional to the current. The other term is just the constant of proportionality. Okay. Sharon, this is an English channel, man. Hindi channels, there are too many Hindi channels. So we have the English channel over here. Okay. Cool. Perfecto. Shall we go ahead? Let's go then. What does this say? Assertion. Step transformers increases the current. Transformer obeys the laws of conservation of energy. What do you think? Okay. Now the logic is voltage in the secondary by voltage in the primary is number of turns in the secondary by number of turns in the primary, which is also current in the primary by current in the secondary. So the ratio for currents is inverse. And this happens because the power in the primary should be the power in the secondary, meaning voltage into current, voltage into what am I doing? Vp into Ip should be Vs into Is. No power loss happens. So because of conservation of energy, this is conservation of energy 100%. And for a step down transformer, V secondary is less than Vp. If this is less, this is more. This will be less, this will be more. So Ip will be less than Is. So what happens to the current? It increases the current. Yes, secondary current is more. So yes, this is also correct. And his assertion and reason, if they are both correct, are they explaining it? Are they explaining it, guys? Come on, think about it. So in a step down transformer, the voltage decreases. So that's why the current increases. And that is based on the law of conservation of energy. Yes, so I think both assertion and reason are true. And the reason is the correct explanation of assertion. Yeah, everyone got it? Perfecto. Let me know quickly in the chat box. Yes, no. Yes, perfect. Let's go to the next concept of alternating current, whatever things are there. In AC circuit, you need to know the phasor diagrams, who leads whom in inductors, capacitors, resistors, the formula for reactances and impedances, and the power formulas, which is VI cos phi, where cos is the power factor of that AC circuit. Capacitive reactance 1 by omega C, inductive reactance omega L, and current and voltage are having some phase difference between them, and the total resistance of the circuit is called impedance, which is R square plus XL minus XC whole square, whole thing under the root. All these things very important. And when current is maximum, then voltage and current are in the same angle or phase. That is called resonance. So you will see XL equals to XC. Impedance is minimum, current is maximum, and that frequency is resonant frequency given by 1 by root LC. All these are standard formulas for AC circuits. Let's see some questions on that. Okay. Why was it option A? Because it was explaining it, Jaisatya, because energy is conserved, and in a step down, what will happen? The voltage will reduce. So what is power? Power or energy? Voltage into current. So if voltage reduces, the other term should increase. So current should increase. That's how you can say that. Cool. Perfect. Perfect. Great. Come on, let's do this. Average value of AC over a complete cycle is always 0. Average value of AC over a complete cycle is 0, because how much your positive is there, that much negative is there. That is correct. Average value of AC is always defined over half cycle. That is also correct. Average value of AC is always defined over a half cycle. Now, the question is whether they are explaining each other or not. Think about it. Think about it. See, the reason why average value of AC is always defined over a half cycle is actually the assertion. Rather, if R was A and A was R, then option A would be correct. But I think now B will be correct. Actually, the reason is the assertion. Assertion should be the reason. Because when you take an average value, the average for that complete cycle, it is 0. But if you just take half of the cycle, the average value will not be 0. And that's what makes sense, because I want to know how much is that AC current increasing, decreasing on an average, and I want to know that average value of either the positive side or the negative side. So that's why we either take one side, positive or the negative side, to define the average. Because for the entire cycle, the positives and negatives will cancel out. So this is not the explanation of this, rather A is the explanation of R. So B is the right answer. Yeah. Is that clear, everyone? Very, very interesting question. Let's go to the next question coming up on your screen, and here it is. In a purely inductive or a capacitive circuit, the current is referred to as wattless current. Okay. No power is dissipated in a purely inductive or capacitive circuit, even through a current is flowing in the circuit. This, I think, is both correct. Yep. In a purely inductive or capacitive circuit, what happens? The current and the voltage both are perpendicular to each other in the phasor diagram. So if you take the power factor, cos 90 will be 0, and that is why it is called wattless, because power will be 0 due to that current in that voltage. No power is dissipated in this circuit even though the current is flowing, because the power factor will be 0. So yes, this is the explanation of it, and hence option A will be the right answer. Option A will be the right answer. Yeah. Okay. Yeah, you can share that, Satyaram gamers. I mean, anyways, the number will be public only, right? So why are you worried? Yeah. Cool. Shall we go ahead? Next one. By the way, this derivation is very common. If impedance has to be found out from the capacitance, inductance, and resistance, what is the derivation for that? Remember the derivations and everything. I made a separate video on our channel. If you just go to search and just type derivation, you will get all the physics 12 standard NCERT derivations. I have made a separate video for it. Please go through it. So that's why I'm keeping this particular question as homework. Derivations may be asked, may not be asked, but if it is asked, then you are going to be in a big soup. EM waves, electromagnetic waves. Light moves in the form of electric and magnetic fields which both oscillate in perpendicular directions, and this particular velocity of the light, if I take c hat is a unit vector in the direction of the light. The direction is parallel to how the electric field cross producted with magnetic field will be. So if electric field is oscillating like this, magnetic field is oscillating perpendicular to it. So if you do E cross B, electric field cross magnetic, electric field is here, magnetic field is there. That gives me the direction in which light is propagating as a wave. And the speed of light standard 3 into 10 to the power 8. Obviously, the speed of light is frequency into wavelength, which is also omega divided by k, which also can be written as 1 by permeability into permittivity's root. This tells me the medium matters in deciding the speed of light. If the medium changes, permittivity or permeability will change, affecting the speed of light. Also, electric field and magnetic field's ratio is also speed of light. Electric field and magnetic field's ratio is speed of light. Yeah. And in that entire electromagnetic waves, depending on who has high frequency, less frequency, you categorize from a certain to certain range of frequencies as a certain type of wave like infrared, Bluetooth, radio waves, gamma rays, so on and so forth. The longest wavelength is for a radio wave, then it becomes shorter in wavelength, higher in frequency for a microwave. Then you go to infrared, then you go to red, to yellow, to blue or violet. Violet has very small wavelength or high frequency. After that comes ultraviolet, and then you get X-rays, and then you finally get gamma rays of very high energy and frequency, but very small wavelength. So that is the where you can say electromagnetic spectrum. Each of them will have some application, some side effects. Like for example, gamma rays are emitted from nuclear reactions, right? And they are very, very harmful. X-rays are used to detect fractures. Ultraviolet is used to kill germs. Visible light is something which you see. Infrared is used for thermal imaging and scanning. Microwaves are used in microwave ovens, right? Radio waves for long distance communication. So each of them has their own applications and uses. There is a beautiful chart and table given in your NCERT. Just go through them because any of it can be asked as a fill in the blank objective or just a one-liner question. Okay, so keep this in mind. This is that table, right? So let's maybe go to some questions coming up on your screen, and here it is. Different electromagnetic waves differ considerably in their mode of interaction with matter. Is that so? Different electromagnetic waves have different wavelength or frequency. Yeah, come on. This is very straightforward. If you take infrared versus ultraviolet, what do you see? Both of them have different wavelength, both of them have different frequency. So different waves have different wavelength and frequency. Perfect. Different waves differ considerably in their mode of interaction with matter. Like X-rays can pass through human skin, but can't pass through bones. But visible light, they can't even pass through skin. Some things are visible, some things not visible, some things, they can absorb, some things will reflect. So it depends on which ray is being passed through that medium. So yes, it depends on it. And is it the correct explanation? Electromagnetic waves have different wavelength and frequency. That is why they considerably differ in the mode of interaction with matter. That is one of the reason, but not the complete reason. So is it explanation, correct explanation? I don't think so. Just try to frame the statement as one single statement with the word because. Because different electromagnetic waves have different wavelength, that is why different waves differ in their mode of interaction with matter. Yeah, that is just the first step, but why does it differ in the mode of interaction of the matter? What does matter have to do with it? That is not explained. Like, how will that wavelength and that matter together decide how they are going to interact? That is not really completely explained in this. So that is why the answer should be B. Yes. Is that right, everyone? Perfect. Let's go to the next question coming up on your screen. All electromagnetic waves travel through vacuum with the same speed, but they have different wavelength or frequency. That is absolutely correct. When you take a medium, permeability and permittivity is fixed. Speed of light gets defined. If frequency is more, wavelength is less, and vice versa. So this is absolutely correct. The wavelength of EM waves is often correlated with the size or characteristic size of the system that produces and radiates them. That is also correct. Like for example, gamma rays comes from nucleus, and nucleus is very small, and wavelength of gamma is also of the size of the nucleus. But if you look at X-rays or ultraviolet, they are coming from atomic interactions and they are having similar wavelengths as the size of atoms. Radio waves and all that, they come from large oscillations of charges over so many meters, and that is the reason why the wavelength is also of that size. So definitely it is correct. But is it explaining why it is going through the medium at the same speed and they are having different wavelength? Well, they are not explaining why same speed and they are having different wavelength. Yes, it is explaining this particular part or frequency, but why is it having same speed? That has to be mentioned in the form of permeability, permittivity. The medium is the same. the speed is the same. So that part has not come over here. So both are correct, but it is not the perfect explanation. It is not the perfect explanation of it. Okay, cool. Let's go to the next question coming up on your screen, and here it is. Radio waves are diffracted by buildings. Radio waves are high energy waves. Now, what is the meaning of diffraction? If you have some kind of opening and if the rays pass through the opening, they spread. They spread. And this effect is called diffraction, and it happens if the wavelength size is almost similar to the size of the opening, is almost similar to the size of the opening or that hole or that aperture. Now, when you talk about buildings, one building to other building, the distance between them is in few meters. Radio waves is also in few meters. So that is why diffraction becomes very common or eminent in cases of radio waves between the buildings. So definitely this is correct. Radio waves are high energy waves. That is absolutely wrong. Their wavelength is large. So wavelength is large. So frequency is less. So energy is also very less. So this is wrong. Assertion is true, but reasoning is false. Hence, C option is the right answer. Yeah, hence C answer is the right answer. Got it, guys? Everyone? Very good, very good, very good. Let's see whether you can give the next correct answer over here. The electromagnetic waves which are used to purify water. What is it called? Electromagnetic waves which is used to purify water. Do we use infrared? No, it's not right. X-rays or gamma will damage you only, forget purifying water. So it is actually UV. You might have seen that in most of the water purifiers, they mention UV, UV filtered, UV purified water. That means when ultraviolet rays pass, they destroy the germs and the bacteria inside, and that is how the water gets purified. So the answer for that is actually ultraviolet rays. Got it? Yes, it is ultraviolet rays. Very nice. Moving to the next question on your screen. Here it is. If electric and magnetic fields represent E and B in a EM wave, the direction of the wave is along which direction? E cross B is always parallel to the velocity of the light. Hence, it is option C, not B cross E. E cross B, electric field cross magnetic field, gives me the direction of the light. Yes, so it is option C. Perfect. Amazing. Amazing. Let's go to mirrors and lenses, guys. We have been doing mirrors and lenses very frequently. So we'll just directly start with the questions now. Standard formulas of mirror formula, the lens formula, very similar, magnification, refractive index, right? So these are also very common questions. So let's see one by one what it is. All right. So focal length of an equiconvex lens placed in air is equal to the radius of curvature of either face. Is that so? For an equiconvex lens, the radius of curvature of both faces is the same. What do you think? What do you think? I think this is based on lens maker formula. This is based on the lens maker formula. The focal length of an equiconvex lens is equal to, lens placed in air is equal to the radius of curvature of the either face. Guys, if you use 1 by f is equal to mu minus 1, equiconvex means the radius are same. So minus 1 by minus r. So it will become mu minus 1. And this will be 2 divided by r. That is 1 by f. So f will be r divided by 2 into mu minus 1. So how is the focal length equal to the radius? I don't think so. For an equiconvex lens, the radius on both the faces is the same in magnitude. Yes. So assertion is false. Reasoning is true. I think such an option is not there. So if there was an E option, that would be correct. So A is basically false and reason is basically true. Both the radius are going to be the same because that's an equiconvex lens, right? So if for an equiconvex lens, what happens? This particular radius and this particular radius, they both will be the same. Hence, E option, if at all, assertion is false, reasoning will be true. That will be correct. Yeah. Very good. Work power energy questions are basically 11th standard questions, not 12th standard. Yeah. Okay. Cool. So we are just doing 12th standard questions today. So let's do the next one. Combination of lenses helps to obtain diverging on converging lenses of desired magnification. It enhances sharpness of the image. What do you think? When you use one lens in a combination with another lens, that what will happen? Either you can increase the power, decrease the power, decrease the focal length, increase the focal length. So because of it, yes, you can get more converging or diverging combinations. So definitely possible. That assertion is true. But what about enhancing the sharpness of the image? That is also true, because when you are magnifying it in a better way, you are zooming onto it, you can see clearly, crisp nature, what is exactly there. So you are getting a very nice image. So is this the reason of it? I don't think so. The combination of lenses adds the power of each lens. That is how you can make it converging and diverging. And the reasoning can't be it enhances the sharpness. That is the result of it. It is not the reason. So this is result, not the reason. So hence, this is not the correct explanation. So option B is the right answer. Got it? Everybody with me? Perfecto. Amazing, amazing, amazing. Moving on to the next question coming up on your screen. There is a biconvex lens. There is a biconvex lens made of transparent material of refractive index 1.25, and it is immersed in some kind of liquid. Will the lens behave as a converging or a diverging lens? Give the correct reasoning for it. Yeah, right. Madhuna, I would say don't buy Ekalavya test series now, because I'm going to give you a surprise in just 5 days. Don't buy anything. I'm going to give a big, big surprise. Everything will come to you at a very good price. Okay? Just wait for 1 week. Not even hardly 1 week. Yeah. So, Zoro, I am doing all important questions. So, definitely it will help you, man. That is the whole point of me standing here taking this marathon for CBSE. Okay? Now, see, guys, I'll tell you what. When you look at the focal length or power formula, power is 1 by F, and that is basically given by refractive index of the lens by refractive index of the medium minus 1, and you have something 1 by R1 minus 1 by R2 over here. Okay, 1 by R1 minus 1 by R2. Forget this part. When you immerse the lens in a liquid, then this will change. Now, usually what happens, if it is in air, power in air will be having, when you talk about power in air, this refractive index of the lens will be 1.5, let's say, medium is outside 1. This is what it will be. The power in that liquid will be 1.5 divided by 1.33 minus 1. So in which case do you think the power will be more? This is 1.5 minus 1, like 0.5. This is 1.5 by 1.33. Yeah. So this value will be less. This value will be more. This is obviously going to be more rather than this. So the power in air versus power in liquid, power in air will be more as compared to the power in liquid. So which in this scenario, so the power is reducing when you immerse the lens. So it's clearly seen the convergingness is changing. So the power of a lens depends not only on the material of the lens and the radius, but also in which medium it is existing. Now just imagine there is some kind of another liquid number 2 which has a refractive index of 1.6. Then what will happen? This entire term will become negative. In fact, it will become so less that it will now become negative. So now instead of converging, it will now become diverging in nature. So if the lens is immersed in a liquid whose refractive index is more than the lens, then instead of becoming converging, it now becomes diverging in nature, because instead of the power being positive, it becomes negative. So yes, the lens converging can become diverging, diverging can become converging if you immerse it in a liquid which has more refractive index than the lens's refractive index. Is that so, everyone? Perfect. Amazing, amazing, amazing. There was one more interesting question on this. There is a convex lens which is placed in contact with a plane mirror, and at a point object is at a distance of 20 centimeter on the axis of this combination and has its image coinciding with itself. The question is, what is the focal length of the lens? Let's redraw it. There was no diagram given. This is a very interesting question. This is the lens. This is the mirror, maybe like this. It is in contact. And there is a object which is placed over here. The object and the image coincide, which means that the rays would have gone something like this. They went through the lens. They have to retrace back the same path. That means they would fall normally on the mirror. So they went like this. They became parallel. Then they came back like that. And they retraced back the same path and fell over here. This means this particular distance should be the focal length. And the focal length is the distance of the object from the lens, which is 20 centimeters. Very simple. Because if you visualize what just happened for that lens, if you think about it carefully, this was the lens, this was the mirror. So the rays coming from the object after passing through the lens became parallel. So they went like this, they hit normally, and they again came back and again made the image exactly at the same place. So if a parallel beam merges, this should be the focal point. So this distance is exactly the distance between the object and the lens, which is 20 centimeters. Hence focal length is 20. Such a nice question, right? Yeah. Yes, definitely TL is equal to MC square. I'll upload the prism and the dispersion class. Not an issue. Let's do some questions on YDSE, guys. Young's double slit experiment, the fringe width, where the fringes are formed, the path difference, intensity of light, nature of the fringes, etc. Those kind of questions. So what kind of things can be asked in your CBSE board examination? Let's have a look. In a YDSE, the fringes for the dark is different from that of white. Okay. In YDSE, the fringes are performed with source of white light, then only black and bright fringes are observed. I think both are wrong, I feel. When you use white light is made up of blue, yellow, green, orange, red, everything. So every color will form a fringe and every fringe will have different fringe width. So they will start overlapping, merging everything. So you will not really get a clear cut fringe pattern, because if some color is giving a dark fringe somewhere, some other color will be giving a bright fringe there. So you will never really see a perfect dark or a perfect bright everywhere. You will see a overlapping of all those colors, infinite set of colors. So no clear cut fringe pattern will be there, and you will definitely not get fringe width for dark is different from that of white. How? No, white, it will not be like white and black. If you pass white light, it will be not like white, black, white, black. No, it will be like green, yellow, orange, mixture of orange and yellow, mixture of red, green, and blue somewhere. So it will not even be dark and white. It is completely, completely wrong. Okay. So yes, both assertion and reason are false. Is that right? Perfecto. Yeah, amazing, amazing. Nishant, I think you have come here after 3 years or 4 years. Shimon sir left the J English channel long, long time back, man. Yeah, now we have Ninja man from a very long time. Last 2 years we are on the channel. And by the way, October marks the completion of 5 years of the channel. Vedantu J English channel was started in October 5 years back during COVID. And today marks the 5 years, not today, this month actually, marks the 5 years of completion of this channel. And it's all thanks to you that we have reached 3 lakh 2000. Now we'll become 303, a special number, 3 lakh 3000 subscribers in just a couple of days. All thanks to your love and support, guys. Thank you so much. Right? Let's go to the next one coming up on your screen. Okay, now this is very interesting. Based on the light waves property, when a tiny circular obstacle is placed in the path of light from some distance, a bright spot is seen at the center of the shadow. The destructive interference occurs at the center of the shadow. See, imagine this is our screen. Okay, you have taken an obstacle. This is the obstacle, and let's say this is some source of light which is emitting light like this, and light rays will go here. So obviously, as you can see, this is basically the shadow. This is basically the shadow, this much part. This is basically the shadow of that object. But still, what will happen, because there is an obstruction, you will see that the light rays will bend and they will diffract. And once they diffract, you will see all the light rays which get diffracted over here, they meet together with zero path difference. So it will be a constructive interference, and that is why you will get a bright spot over here exactly in the shadow. So this bright shadow is also called as young, I think who performed this? Fresnel, if I'm not wrong. Fresnel was that scientist who demonstrated this shadow, or Young, one of them. And this bright shadow is seen in the shadow of that obstacle due to diffraction. And destructive, no, it is constructive interference. So this is wrong. Assertion is true, but reasoning is false. So option C is the right answer. Option C is the right answer. Got it, my dear warriors? Perfect. Yeah. Let's go to the next question then. Let's go to the next question. Okay, perfect. Let's see. So we have no interference pattern is detected when two sources coherently are infinitely close to each other. The fringe pattern is inversely proportional to the distance between the two sources. Fringe width is lambda d by d. Now just imagine in this scenario, no interference when two sources are infinitely close to each other means small d is close to 0, then the fringe width will become infinitely large. So you will not see only the interference pattern in a way, okay? And fringe width is inversely proportional to the distance between the two sources. Absolutely correct, absolutely correct. And this is explaining why when the fringe width will become so large, you will not see that bright and dark fringes. So yes, this is the right answer, option A. It is explaining it in a correct manner. Yes, for a final time, we have option A. Correct, J aspirant. Hi, Wu, nice to see you. Very good, very good, very good, very good. Awesomeness, awesomeness. Very good. So I have kept a homework question for all of you. Please try to solve it. Okay, it was asked a long time back. Everything is given. Lambda is given, D is given, D is given. Question is, no, not D and D is given. Lambda is given and separation is given. Find the wavelength which will produce a new fringe width of so and so. So use the beta is lambda D by D formula. You will get the answer. It is very, very simple. Okay, so this is your homework question. Let's go to some photoelectric effect based questions now, where light falls on a suitable metallic surface and emits electrons. That is called as photoelectric effect. And you will see that there is a threshold frequency depending on the work function of a metal below which no photoelectric effect is occurring. Once you cross the threshold, photoelectric effect will occur. And if you increase the intensity of light, then you will see the current in that circuit will increase through that metal. But remember, in order to stop those electrons, you apply a reverse voltage called as the stopping voltage, which depends on the kinetic energy of those electrons emitted. So it depends on the light's energy and the work function and all of that. And these effects are based on the uh, particle nature of light, not the wave nature. So for which Einstein and Planck, they won the Nobel Prize, right? So the photoelectric equation, the energy of the light is work function plus the kinetic energy. That is very, very important. Let's look at some questions coming up on your screen, and here it is. Wow, a big theoretical question, guys. Let's have a look at it. Very interesting question. Okay. Ready for it? For the radiation of a frequency greater than the threshold, photoelectric current is proportional to the intensity of light. This is absolutely correct. Current is proportional to the current if frequency is more than the threshold frequency. So assertion is absolutely fine. Greater the number of energy quanta available, greater the number of electrons absorbing the energy, the quanta, and greater is the number of electrons coming out of the metal. This is exactly the reason why this happens. Perfect. So if you have more light falling, more intense light, more photons, that is the quanta falling, so more quanta will interact with more atoms, releasing more electrons will make up more current. That is why current is proportional to the intensity. So in this situation, obviously assertion is the right answer. Rocking lifestyle, I'll try to do it in the couple of days to come. Yeah, don't worry. Is that so? Cool. Let's go to the next question. Here comes on the screen. Photoelectric effect demonstrates the wave nature of light. The number of photoelectrons is proportional to the frequency of light. Photoelectric effect does not demonstrate wave, it demonstrates particle nature of the light. So wave is wrong. Number of photoelectrons is proportional to the frequency. No, it is proportional to intensity of light. So both are wrong. Hence, option D is the correct answer. Yeah. Sir, if I took course, can I get JEE exams cleared now in school? JEE means I just got 70 marks only, sir. I'm Siva, you have quite some time for 11th standard. I think I should make a separate video what you should be doing. Don't worry, we'll help you out. But if you are getting just 70 marks right now, I'm not sure what you are talking about. JEE, I'm guessing, for out of 300. It's not something to be sad about right now because you have 1 year of time. But if you follow the right plan, at 70 will become 100, it will become 120, and slowly 150 also. And once you reach 170, 160, that will give you the confidence that now you are closing on 98, 99 percentile. Yeah. So slowly you'll have to work hard. You have to clear your backlogs, redo whatever you have missed, and obviously joining a coaching will help you. Yeah. So that's why please give MVSAT. It's online. It will tell you where you stand and also give you free resources, and then it will also give you scholarship for seeking admission in Vedantu courses. Okay. The link for MVSAT is there in the description box. So let's go to another question coming up on your screen, and here it is. The variation of stopping voltage with frequency of a light for ABCD is given. For same frequency, the kinetic energy will be maximum for which metal? For same frequency of incidence. So, energy of the photon which falls is equal to the work function plus kinetic energy. Energy of the photon is hf or h nu, whatever you want to call it, is work function plus kinetic energy. Now this has not changed, so this is same because it is clearly mentioned for the same frequency of the incident light. So I want the kinetic energy to be maximum, so the work function to be minimum. That is what the question demands us. So work function, the formula for it is nothing but hf naught. So if I want work function to be minimum, threshold frequency should be minimum. Out of all of them, this is the threshold frequency, which is the least. This is maximum. So A should be the right answer. A should be the right answer. A has the least threshold frequency. This is frequency, I can say axis. This point where it interacts with the horizontal line, that is the threshold frequency. So of all the metals, A has the least threshold, least work function. So most of the energy is available in the form of kinetic. That is the right explanation for it. Right? So let's go to Bohr's model of atom, where angular momentum quantization, energies are quantized, then centripetal force is provided by electric force, finding radius, finding velocity, finding the potential kinetic energies, those kind of things, atomic spectra, all those kind of topics are very, very commonly asked, right? Rydberg's formula, right? All these things. So let's have a look at this, and also you should know the atomic spectra, uh, the lines, Lyman, Balmer, Paschen, okay, from which transition to which transition, and the region as well. So let's do some questions on it. Here it is. Bohr had to postulate that electrons in stationary orbits around the nucleus do not radiate. According to classical physics, all moving electrons radiate. This is very interesting. In fact, based on perfect theory, when Rutherford described the atoms to be relatively empty and entire mass, charge, everything of the positive is concentrated in the nucleus and the electrons are revolving, he was not able to explain Maxwell's radiation, which stated that if electrons are orbiting, they're accelerated particles, so they should emit energy, radiate energy, and if they lose energy, they should finally collapse onto the nucleus. So, according to classical physics of Maxwell's radiation, all moving electrons should radiate. That is absolutely correct. But Rutherford, Thomson, nobody was able to explain that phenomenon. Bohr said that actually a standing wave pattern forms of the matter waves of electron, which keeps those electrons stable in certain orbits only. If they change the orbit, anything else, then it will radiate energy. So only in certain orbits, stationary waves which conserve the energy, maintain those orbits, and that is when the orbits are said to be stationary orbits and they do not radiate. So both are independently correct, but it is not really explaining why Bohr said that, why it is not radiating, how was he able to overcome that dilemma which Rutherford faced due to classical physics. So B is the right answer because it is not really the correct explanation. Yeah. For Sigma batch students, Sigma crash course, you need not buy, man. You don't have to buy. Revision is planned for you. And I will explain it to you, Ashwant, in the Sigma batch, what exactly is going to be done. Okay. So you don't really have to buy crash course if you're already a Sigma batch student. Yeah, because revision, everything is planned for you. Cool. Done. Pakka. Yeah. Perfect. Perfect. Let's go. Let's go to the next question coming up on your screen. And here it is. It says the energy of an electron in the ground state of an atom is minus 13.6. The kinetic and potential energy in the first excited state will be, wow, very interesting. Energy in the ground state is standard minus 13.6. But the question is, what will be the kinetic and potential in the first excited state? First excited state means n is equal to 2. So energy in the second state will be minus 13.6 divided by n square, that means 2 square electron volt. Okay, so how much will that be? Minus 13.6 divided by 4, guys. That's, I think, going to be minus 3.4 electron volt. That is the total energy, by the way. This is total energy. Now, obviously, this is the sum of kinetic and potential energy. And there are standard formulas which says kinetic energy is just the negative of the total energy, and the potential energy is just 2 times of the total energy. So negative of this means negative of minus 3.4, which is just 3.4 electron volt. And 2 times of minus 3.4 is nothing but minus 6.8 electron volt. So kinetic is 3.4 and potential is minus 6.8. So option C is the right answer. Very straightforward. Correct? Yes, no. Very good. Very good. Excellent. Amazing. Amazing. Let's do another question coming up on your screen. I think it's on now semiconductors. Yes. Semiconductors, let's have a look at those PN junctions and also the doping, energy bands, valence band, conduction band, band gaps, what kind of material is used, conductivity of a semiconductor formula, intrinsic, extrinsic semiconductors, then barrier potential, forward bias, reverse bias, diffusion current, drift current, new voltage, diode working, IV characteristic, diode as a rectifier. These are major topics on which majority of the questions are asked. So please go through these topics. Right? I'll just show you some questions which have come or which are very important. Like for example, this one. There is a pure semiconductor crystal having so many atoms and it is doped with 1 ppm concentration of antimony. The whole concentration is this much. Concentration of intrinsic charge carriers is how much? Okay. First of all, let's understand that this antimony is basically a donor impurity. This is a donor impurity. It is a pentavalent pentavalent impurity. Pentavalent impurity. That means the semiconductor type will be N type. This is a N type of semiconductor. Now, this 1 ppm stands for there is 1 electron for 1 million. 1 million is 10 to the power 6 atoms. But the actual atoms are so many. So, how many electrons are there? So, number of electrons which are going to be there, think like this. For every 10 to the power 6 atoms, there is 1 electron. So, how many such millions are there? How many such millions of atoms are there? If you calculate, that's it, your job is done. So, you have 1 electron for every 10 to the power 6 atoms. So, if you have 5 into 10 to the power 28 atoms, how many electrons will you get? 6 and 28 cancel. So, you will have 5 into 10 to the power 22 electrons per meter cube. That is the concentration of electrons. Next important thing, this one. This value is nothing but NH, number of holes which are there. Holes, NH. H for holes, N for concentration. Now we all know the formula. Ni, intrinsic concentration square, is electron concentration into hole concentration. So Ne is 5 into 10 to the power 22. NH is 4.5 into 10 to the power 9. Now 4.5 into 5. How much is it, guys? 4.5 into 5. Come on, tell me quickly in the chat box. 225. So 22.5 multiplied by 10 to the power 31. If you write it in a slightly better form, 225 into 10 to the power 30 is basically Ni square. So Ni will be root of 225, which is 15, and root of 10 to the power 30 is 10 to the power 15. So 15 into 10 to the power 15, or basically 1.5 into 10 to the power 16, is the intrinsic semiconductor concentration, which is option B. Yeah. ISC classes, Vijay Lakshmi. Yo. How many students are there, man, for ISC? If there are only like few students, then it will become very difficult for me to conduct it. But yeah, if you have more kids, then you need to comment then and demand for it. Whatever the demand comes, see, it works based on demand and supply, man. It's very straightforward. Yeah. Let's see if we can answer this. Oh, this one. Explain characteristics of a PN junction diode that make it suitable to use as a rectifier. So the characteristics which help it to be suitable are the IV characteristics, where if you draw the current versus the voltage graph, it looks something like this. Initially, hardly any current is there, then it starts increasing, whereas here it is negligible until the breakdown happens. So this is the forward bias, this is the reverse bias, and a PN junction diode, you can say that when the current flows in it like this is forward bias current, which is not zero, and it is significant, but when you pass the current, try to pass the current in like this, the current in the reverse bias is as good as zero. It does not conduct. So when the current is going from the P side to the N side, it is forward, but when it is going from N to P, it is the reverse. This property of allowing the current in one direction and blocking the direction of current in the other way is useful for making a rectifier. Rectifier is a device, rectifier is a device which converts bidirectional current, which is AC, into a unidirectional current, which is basically DC. For example, if you have an AC current, which is over here, if you have an AC current over here, and you just use one normal diode and pass that current through a resistor, and you measure the voltage across the diode, you will see when this positive half cycle is going on for a AC and the positive half cycle is going on for AC, this diode will become forward biased, it will become conducting, and you will see the voltage come across this resistor. But when the negative cycle of the AC starts, that means this is negative, this is positive, this diode will become reverse bias and there will be no current in the circuit, and that's why you will see nothing over here. So the input, you can see this is the input, which is an AC, which is having both the directions, but the output has only the one half of the positive cycle, which allows only the current to flow in one direction. So you have converted bidirectional current into a unidirectional or a single directional DC current. So that's how you can use a diode in the form of a rectifier. This particular situation is called as a half-wave rectifier because you are only taking in half of the complete AC cycle. But if you use this cycle, second half, and converted that, mirrored it on the top, then you would be using both the halves of the complete AC cycle. So that is called as a full wave rectifier, which is much better than a half wave because wastage is not there. A half-wave rectifier works only for positive half cycle of AC, which is absolutely correct. And in the half-wave rectifier, only one diode is used. This is also correct. But is it the correct explanation? Only works for the positive half cycle? Is it because one diode is used? Yes. But how is it explaining why only the positive cycle? Why not the negative cycle? Is it completely explaining it? So it is option B is the right answer. Yeah, I hope this is absolutely clear. So these were some of the important CBSE questions: assertion, reason, reasoning based, derivations, numericals, explanations, etc. So I hope you saw what is important and what is not. But let me tell you, we have to do more than this because this will just bring you till 75%. Okay, but beyond the 75%, 80% mark, you have to work really hard and push yourself for the difficult paper. Because at the end of the day, it's not about just remembering, it's also about writing, having that strength in the exam, not losing focus, and continuously, writing takes away a lot of energy. It is not like bubbling or tick marking in JEE Mains. So you need to practice a lot, plus go through PYQs, which we'll be also doing here, do those case study based questions, which we'll be doing here, and those big questions which carry heavy weightage, right? So see you for the next time. And also, yes, VIT Triple E students are demanding. If you want that, you need to put up those demands in the comment section. Simple. Demand, supply. If you put the demand, we will do it. You don't put it, I will not get some dream that you guys want it. Okay. Although I talk to students and students tell me what they want, but if there are more students liking the same comment, etc., then I will know, okay, this is what we need to do, right? So thank you for liking, thank you for subscribing, guys. I'll see you again after 2 days. There is one amazing mini series which we are going to launch for all the beginners, all the average students. In just 5 days, we are going to create a history. Okay, what is that? I'll tell you in just 2 days. Tomorrow and day after tomorrow, Namrata ma'am and Diksha ma'am's classes are there. Same, but we'll be concentrating more on the numericals and question side. So make sure you are marking your attendance for chemistry as well as the mathematics lectures. Okay, right? So thank you so much, guys. Have a great time. Subscribe to the channel. Do not miss out on any of the classes. A lot of things are going to keeping you occupied for the next 2-3 months. Okay, bye bye. Take care.